produce low quality radiographic image which will form a shadow and a blurry image. So in my work, I study the effect of external fan beam type collimators parameters in conventional transmission X-ray radiographic imaging. Next slide. So the aim of my study is to prove that the use of fan beam type collimator in conventional X-ray radiographic imaging can produce comparable quality image with the existing imaging system. So there are few optimization parameters that need to be concerned, which is the source aperture of the X-ray beam exit, the focus spot, collimator slit size, and collimator scanning speed. Next slide. So here is the research flow chart of my project. So first, I will brief about the sample and setup preparation. And next, I will give a full explanation about the determination of beam size and focus spot effect on the radiographic imaging. So for this part, I will talk about all of the methodology and result for uncollimated setup. And then I will move to the determination of collimator size and scanning speed on radiographic imaging. So in this part, I will talk about all the methodology and results in the collimated setup. And lastly, I will analyze the radiographic imaging using CNR. Okay, proceed to the next slide. So figure 2 shows the schematic diagram of the conventional transmission X-ray radiographic imaging. So here is the full dimension of my experiment. Okay, so here we have focus spot, X-ray focus spot, and the beam will go through the beam exit, which have a source aperture, and the beam will pass through the samples and detected in the on the imaging plate. The next slide. Okay, so here, as you can see, at the upper left of the slide is figure 3, which is the image of sample. So figure A is the image of sample which placed in a box, and image figure 3B is what it looks inside the box, and figure 3C is the image that we get from the uncollimated setup that I have shown earlier in the previous slide. So in figure 3C, as you can see, for the background, we use flower as the background, which have the lower Z effective, and we have 4 types of sample, which consists of low Z material, which are paracetamol and organic fertilizer, and the high Z material, which is razor and coin, as tabulated in table of Z effective of each samples. So to study the contrast of all the samples respective to the background, so we adopted the equation of CNR, which is contrast noise ratio, which shown at the bottom left of the slide. Okay, so the mu1 is the peak sample minus mu2, which is the peak signal of the background, and divided by total standard deviation of both samples and background, as depicted in the figure at the left at the right side of the equation, where in the blue circle on the picture, as we can see, is associated with the blue histogram, okay, in the graph, and the red circle are associated to the background of the histogram. So from this picture, we will extract the information and use it to calculate the CNR. So figure 5 in this slide shows our histogram of background and all of the samples. Can we proceed to the next slide? So here is the facilities that we have used at Agency Nuclear Malaysia. So this experiment was done at Agency Nuclear Malaysia. So figure 6 shows the Philip Industrial X-ray source that we have used to irradiate the samples, and figure 7 shows the CAD-stream direct view computer radiography, or we call it CR, to record and analyze the image. Next slide. So here is the more description about beam size and focus spot effect studies. So here we have 4 sets of criteria, which is we need to study about the source aperture and focus spot combination. So table 2 is the experimental setup criteria for beam filtration experiment. So criteria A, as you can see in a figure at the left side, we irradiate the samples with a bigger source aperture and bigger focus spot, followed by irradiation of small focus spot with a big source aperture, and then we proceed with the big focus spot and small source aperture at the beam axis. And lastly, we also did for using small focus spot and small source aperture. And not to forget that our anode voltage is constant at 40 kV, because we need the image to have constant intensity, and we want to study about the contrast, so we vary the anode current, and we have 5 settings of the anode current, which is 1 mA, 1.25 mA, 1.50, 1.75, and 2 mA. And the exposure time is also varies about 6 settings, 1 to 100 seconds. Next slide. So here is the result of the images recorded using the uncollimated setup just now. So I have put here the result of each samples, as we can see in the slides. Okay, so this plot is a top view 3D plot for all samples at 4 different conditions, which is the condition that I have mentioned just now, the criteria. Okay, the color bar represents the CNR value. Okay, and viewers need to note that the x-axis is the exposure time of the irradiation. So the y-axis is the anode current, and z-axis is the CNR value. So in this slide, as we can see, the range of CNR for each material increases for materials with higher Z effective. So for paracetamol, the CNR range is 1 to 8.4. For fertilizer, we can see the range of CNR is 3 to 7. The razor is from 4 to 18 and coin is from 10 to 50. So the overall pattern of CNR increase with respect to the exposure time and anode current, which ranging from 1 millia to 2 millia. Okay, but even though the overall pattern of CNR increased, the CNR value was inconsistent at certain areas. As we can see for the criteria A, B, and C for all samples. This was due to the radiation leaks that was seen for all samples during the irradiation procedure. So as from our view, plot B, which uses small source aperture and small focal spot, produced steady signals where weak signals were recorded at lower exposure time and the signals increased steadily as the exposure time increased without any radiation leak spotted. From all four conditions, it can be concluded that the combination of beam exit and focus spot are very important to reduce the geometric unsharpness. Okay, so but however, the fertilizer signals is not as consistent as the other three signals because of the variation of the elements in the fertilizer. Okay, next slide. So by using the setup that we have got previously with the beam exit of 4 cm and focus spot of 1 mm, we modify the setup by putting a moving slit collimator between the beam exit and the test object. And we try to record and analyze the image. So figure 10 shows the experimental setup with a moving slit collimator. And figure 11 is the full dimensions of the moving collimator that we have fabricated using lead and mold and being molded in using aluminium mold. Okay, so we have 5 different slit sizes, which is 5 mm, 8 mm, 10 mm, 12 mm, and 15 mm. So the thickness of the moving slit collimator is customized to 1 cm in order to make sure that the X-ray will not pass through the collimator during the irradiation takes place. And the side region of the collimator need to be long enough so that when the scan runtime, the X-ray will not penetrate through the collimator. Okay, so figure at the bottom shows us the illustration of the moving slit collimator configuration. So the horizontal linear slider will make sure that the moving slit collimator move in a horizontal direction while scanning procedure takes place. Can we move to the next slide? Okay, so figure 13 shows the real setup of horizontal linear slider for moving slit collimator. Okay, so figure 13A is the hardware setup and figure 13B is the setup during the scanning procedure. And as we can see, there are few parameters that need to be concerned in order to study the collimator speed and collimator size. So we cannot achieve the exposure time of same with the uncollimated setup previously. So we fix the slit scan time about 5 fixed time, which is 100, 68, 36, 18, and 7, with respective of the stepper motor, RPM, and also the slit scanning speed. So we also have 5 slit scanning speed results from the stepper motor RPM. So in figure 14 is the image of the samples during the single shot irradiation, which is illustrated by figure 14a. Okay, as we can see in figure 14a, only 25% of the image is successfully recorded when the slit collimator was not moving. And we also see that there is a radiation leak spot. Radiation leaks fell onto the detector at the edge of the collimator. For figure 14b, we have successfully recorded the image of the object while the moving collimator move at a continuous scan image. Okay, so for each of the samples, the shadow appeared around the samples are results from scattered radiation produced at the edge of each sample during the imaging procedure. So this shadow is called penumbra effect. So the penumbra effect of coin is more obvious than other samples because the coin have the highest Z effective. Next slide. So here is the figure of the real setup experiment at Agency Nuclear Malaysia. So figure A is the setup inside the irradiation bunker, and figure B is the setup at the monitoring area to control the X-ray during irradiation takes place. So next slide. So yeah, this is the result for the effect of slit size with constant scanning speed. As we can see, for each samples, we have 5 scanning speed, as I have mentioned earlier in a previous slide, from the lowest speed, which is 5.71 millimeter per second, and the highest speed, which is 0.40 millimeter per second. Okay, so this figure is the top view 3D plot for all samples. Viewers must note that x-axis is the slit size of the collimator, of the moving slit collimator. Y-axis is the anode current, and z-axis is the CNR value. So as the slit size increase, the CNR is increasing, but we can see that during the scanning procedure of 0.6 and 0.4 millimeter per second, there is more than one brighter yellow spot at the plot. This is not the scattering effect, because As we can see, the CNR range is quite lower than the CNR range produced during the uncollimated setup. So this is the signals that possessed by the paracetamol, fertilizer, razor, and coin. So can we move to the next slide? So, and for these slides, we have also plotted the top view 3D plot for all samples, which also corresponds with the collimator slit width. So we have 5 collimator slit width, starting from the smallest one, which is 5 millimeter, up to the largest one, which is 15 millimeter. So from this plot, it also shows that as the scanning speed decreases, the CNR also increases. Okay. Next slide. So here is the summary of the plot from the uncollimated setup and the collimated setup. For paracetamol, so the CNR range of produced from the uncollimated setup is from 3 to 6.5, and the collimated setup produced about 0 to 5, which is lower than 6.5. So all of the CNR value produced by the collimated setup is quite lower than the uncollimated setup. So we can conclude that the signals of the signals produced from the collimated setup are the real signals possessed by the paracetamol, organic fertilizer, razor, and coin, with no scattering effect. So next. Can we move to the next slide? Yeah, so can you make it appear, the description of this table? Only the table one. Okay, thank you. So this table, so from the result that I have shown earlier, we need to determine the saturated CNR. So to determine the saturated signal of each sample. So for non-collimated setup, the saturated CNR is, as shown in the table, for paracetamol is about 5.61, and fertilizer is about 4.69, razor is about 14.04, and lastly coin is about 31.31. Okay, and there are also all of the saturated signals for the collimated setup, as we can see in the table here, and we differentiate this CNR value by plotting it in the normalized form. Can you yeah, thank you. So this is the normalized plot of the saturated signals, which shows us the comparison between the non-collimated setup and the collimated setup. So the red bar is for non-collimated setup, for each samples, and the blue color is the collimated setup for each samples. So as we can see, the smallest slit size will produce the least signals when compared to the non-collimated setup, and it increases as the slit size increases. So the largest slit size producing a comparable CNR value with the non-collimated setup. Next slide. So as for conclusion, the source aperture that is suitable for our phantom is the smallest source aperture, which is 4 cm, and also by using a focus spot of 1 millimeter, which is the smallest focus spot. When we use the moving slit collimator, so the collimator slit size that is preferable for our phantom is about 15 millimeter, and the collimator scanning speed is the slowest one, which is 0.4 millimeter per second. Okay, so in this study, we have had successfully proved that the certain slit size and scanning speed of fan beam type collimator only can produce comparable quality image with conventional X-ray radiographic imaging without any external collimator installed in front of the beam exit. So, recommendation from our findings, higher energy X-ray will eventually give higher CNR when using collimated setup, but the test subject density need to choose wisely. Next slide. So huge thanks to the sponsorship of Beasiswa Zamala UTM and also all of the research grant, and my heartfelt thanks goes to the Magma Physics Perubatan Agency Nuclear Malaysia team who gave us the opportunity to perform the research study and also use all the facilities there. So with that, thank you.
Right, thank you so much to our presenter, Ms. Nurdiana Ramli, for presenting her interesting work on the low energy radiography imaging. So next, I would like to invite our second speaker, which is Mr. Fahmi Ibrahim, to present his work on the evaluation features for tracking reconstruction of the muon to electron conversion through algorithms. Without further ado, please welcome.
Bismillahirrahmanirrahim. Thank you, Chairman. My name is Fahmi Ibrahim from University Technology Malaysia. So today I'm gonna present about my current phase of study about evaluation of features importance for tracking of muon electron conversion through various algorithms. So next slide. So here is overview about my research. I will introduce about COMET phase 1 and tell you how I work the simulation from the truth data to get the real mimic like simulated response and extract information, and we cut the data and we train the data to get comparison in terms of feature importance, and we decide which algorithm is the best for the tracking study. Next. Okay, so here is introduction about COMET phase 1. So COMET phase 1 is stand for coherent muon to electron transitions. COMET phase 1 is designed to search the charge lepton flavor violation process, which is the violation of lepton number when muon directly decay into muon at the energy 105 MeV. So in the COMET phase 1, there are three main components. There are pion capture sections, muon transport solenoid and cylindrical detector. Cylindrical detector and known as CIDET, it composed of Cherenkov trigger horoscope and cylindrical drift chamber, and at the center of this detector has a muon stopping target as an aluminum. Okay, so in this experiment, it expect there are one of the expected muon process like a mu 2e gamma, mu 3e, or mu 2e. Okay, so this experiment start with 8 GeV protons is bombarded to the graphite target at the pion capture solenoid at the center. So it want to produce a lot of pions. So that pions will decay, will transport to the via the muon transport, and that pion will decay into the muons. So once it's that muon reach the detector and stop at the muon stopping target at the center of the detector. So it will capture by the aluminum target, and it will decay. That muon will decay into electron, and it pass through to the detector, and in the form of heat. Okay, so this study will study. So the main detector for the reconstruction track mu to E conversion is the TTH and CDC. So physics experiment in Comet Phase 1 starts in 2021 in investigating such rare event involving big data analysis, the tracking reconstruction algorithm are studied. Next. So here are my objective of the research to determine the features important from muon processes. We train the data, the output data from the detector response using the algorithms, and determine the best algorithms suitable for the tracking reconstruction process. Next. Okay, here is about simulation. This is called iNuSTEC simulation. So the way we start the simulation is we use the input file from the MC5A02. We simulate the particle through the SimG4. Okay, so once we simulate and we get the output from the SimG4, then we continue simulate to the SimHitMerger, because we want to in SimHitMerger we need to merge all the files to get we need to get the we need to merge all the data based on MC5A02 specification. In MC5A02 specification, we have a proton per bunch is about 60 million proton on target, and total proton on target is about almost 1 billion, and total proton bunches is 62, and bunch separation between each bunch is about 1170 nanoseconds, and the main detectors for the tracking reconstruction are CTH and CDC. So once we merge all the events, so we get the output. So the output we proceed to sim detector response, because we want to produce data like a real experiment data. Then after we simulate the sim detector response, we get the data. We extract the data from the detector response. Okay, next. So here how we add the signal electron in the simulation. So basically MC5A02 is a standard file MC5 simulation in the SIDET geometry performed by Gen4 with standard model, which means there is no mu to E conversions. Okay. So this file contains information of a muon from the exit of muon transport solenoid, and physics processes occur when muon hit the target. So since there's no mu to E conversions, okay, so what we need to do, we need to add electron signal in these simulations. So the conversion of electron coming out of the muon stopping target is selected. So we have two options to generate this signal electrons. Okay, so either we set the mu mu to E ratio conversion equal to 1, or we can use a uniform sampling from the uniform sampling from the aluminum disc. Okay, as we found the output of after we add the electron signal, we get at the top plot we found that there's a lot of electron signal tracks which are well defined in the CDC detector, and looks consistent in the detector. And below's plot show that to confirm the existence of the mu to E conversions, we look the energy, we look the momentum. We see that momentum distribution of the signal electron we found at the end of distribution we have a 1/5 MeV. Next. Okay, next, since we already generate the signal electrons, we need to merge the signal electron with background event. So, in order to produce a realistic data set, we need a very few signal event needed in the detector compared to the background event rates. So, we need a signal sample treated with a different procedure compared to the background samples. So what we do, we need to we merge the signal with the background using a cherry pick feature in heap merger, which is cherry pick feature. We select the best or cardinal tracks in the simulations. Okay. Okay, so if we want to, since we already merged all the events, okay, so we need to check the existence of the electron signals through the cherry pick ID, the ID track of each bunch is checked one by one, and every bunch should has a different track ID. Next. Next. Okay, so here is after we merge electron signal with the backgrounds. So as we found that the track ID of the cardinal track in each event merged in this label by cherry pick track ID. Okay, so we found at the top is the track from the mu to E conversions in the CDC at a certain range. Okay, the below show the below plot show the momentum of the mu to E conversion. Sorry. Next. Okay, so next we do study about the background effect on the bunch strain. So since we already merged. Okay, so we have a 62 bunches we already merged into the single bunch strains. So in this part, we see clearly the tail of each bunches is continuous to each other. Okay. Since as we know, the particles from the pioneer production take a few milliseconds to reach the detector. Okay, so if we can see that, for example, we can look at the number number 4, which is represent for bunch number 4. We are like during the bunch number 4, we are likely to detect the hits from the bunch number 1, number 2, and number 3, so that the background rate is higher than if we had a single bunch. Okay. Next, we study also the background about the effect of bunch width we set at 0 nanosecond and bunch width 100 nanoseconds. So the top plot there are comparison CDC and CTH 0 nanosecond, and the below is 100 nanoseconds beam width, bunch width. Sorry. Okay, so bunch width with 0, we found that about 40 to the heat, we found that 40 to 100 nanosecond is the beam flash okay, which is can be separated from the muon stopping target radiations. Because with in the CDC, with at the second peak, okay, we found the slow decay indicates how the muon bound lifetime result in delayed background hits. Okay, so for the CTH, the lower plot, the lower plot, we see that the beams look smearing after we set the bunch with 100 nanoseconds. Okay, and push the time of the T earliest hit to T equal to 0, and the tail of the in the CTH is caused by the neutron background, which is CTH has a larger cross section solid volume of than the gaseous volume of the CDC. Next. Okay, here is the analysis. We start to validate where is the muon stop in the stopping target. So we see that most of the muons stop at the top right of the muon stopping targets, these aluminum targets. Okay, and we found there are 17 these. Okay, and we want to know which these are most of muon stop. Okay, we found that at the fourth disk and the second disk, most of our muon stop. Okay, and then we calculate the number of muon stop the target disk per proton on target, and I compare with the previous study, and it looks like the statistic is slightly higher than before. Okay, next. Okay, next we proceed with the machine learning. So once we already accept the information from the SIM detector response, so we want to so in the data since we already extract the data, so we have a lot of information. Sometimes there are some information we don't really need it. Okay, before we train and test in the machine learning. So what we need to do, we need to do data cleaning. We want to remove unwanted information and create a new data set. Okay. So in this study, I do some pre-processing, do the feature selection, okay, of by evaluating through the features importance. So the feature selection is a powerful method which is evaluate the features important that contributed in the model. So there are some of example techniques such as features importance, univariate selection, and correlation matrix with heat map. So the current phase of study, the feature selection are used to classify between electron and positron in the CTH detector from a bunch of protons. Since the main detector CTH and CDC, the information of CDC could not be extracted due to malfunction of SIM detector response for CDC. However, most of the features come from the CDC. Next. Okay, so here is we prepare our data. On the left side, we already this original data we extract from the SIM detector response. This is data from CTH with one bunch proton. Okay, so there's a lot of particles there like gamma, neutron, proton, heavy ions. So we want just in study track reconstruction U2E, we just want only electron and positron. Okay, so we remove the data that unwanted particles, so accept electron and positron only in the data set. Next. Okay, here we start with the models or algorithms. So this is a base algorithm or decision tree. Yeah, decision tree is a weak learner algorithm. So below is a example of decision tree that I get from my results. Okay, so there's a lot of branches, but I choose certain level of the tree. Okay, so in the top of the tree is called the root node. Okay, and the second line, the second level is called the nodes, and the output and we call the leaf. Okay, so in order to determine the best fit of nodes, we use the Gini index. The below is the calculation of the Gini index to which is if we want to see either we want to speed how the probability of the speed on the certain features. Okay, and the other method we can use the entropy, but the easiest one I choose is Gini index. Okay, next. Next. Okay. So this the other algorithms is called random forest. Okay, this is based also decision tree. Random forest is actually is assemble algorithm. So how it works is from the it creates the individual tree from the bootstrap data set, which is, for example, you have a original data set. Okay, is it creates another data set that calls bootstrap data set. Okay, is randomly selected the features and information from the original data sets. So every time it creates the tree, and every time it creates the tree, it also creates a new. It needs to create a bootstrap data set. Okay, and out of that, in random forest, it used to ensure the interpretability works well in decision tree. Okay, for example, you have some data in original data sets, which is does not end up in the bootstrap data set. So out of that, in the random forest, you use to do interpretability. So, for example, that data is certain lines, which is does not end up in the bootstrap. That data from the original will evaluate in the each tree already built by the random forest. So okay. So random forest will combine the result at the end of the process by averaging or majority voting. Next. So this another algorithm is gradient boosting, and gradient boosted decision tree is very powerful, and this is state of art algorithms is very famous, that is very used currently used in the YouTube, Facebook. Yeah. Okay, so the gradient boosting is a combine many weak learner. So weak learner is decision tree. Okay, so it's a weak algorithm. So what gradient boosting is, it will combine all the trees that we have into a single, into become a strong learner. Whereas a GBT combine the output of many decision tree using a gradient boosting methods. Okay, these models typically use classification and regression trees that call CARs. These algorithms are to optimize the loss function of the previous learner. Okay, so we have if decision tree, actually we have a lot of error. Okay, so once we in gradient boosting, if we have a lot of tree, actually it improves the accuracy of the model. Okay, there's three main components in the for the gradient for this algorithm. The first is loss function to optimize the error, and the loss function is must be differentiable. And weak learner is to compute the prediction and form the strong learner, and additive model to regularize the loss function, and which fix the loss function from the previous weak learner. Next. So here is the results from the features importance. We compare to the algorithms. as we found that decision tree is the weak learner, so we found is very worst result. Okay, and we see that for all algorithm, the just deposition show that the highest reading compared to the other features, so, position, timing, and energy depositors. And what I can conclude is the CapBoost algorithm shows prominent features importance count for all criteria compared to the other algorithm. Since all algorithms are set in default, set to default. Okay, so I didn't set any parameter to adjust it. I just set all defaults only. So CapBoost show huge different number different in features important due to huge number of iterations, and the learning rate which is 0.01, is the if we have a lower learning rate is give a better prediction for the model compared the others. Okay, next. Okay, for the conclusion, the electron signal are simulated to the iNuSTEC framework, and we already calculate the muons topic in the target per POT, and the classification of electron and positron in the CTH data for a bunch have been studied, and the feature important of algorithm are evaluated and compared. The main feature for this study is charge deposition, whereas the other features looks inconsistent in various algorithms. And current results show the CapBoost outperform compared with the other algorithm. And the information from the CDC detector is required because we want to achieve the comet benchmark by creating a local features, neighbor features, and track features. And lastly, the future work is to reconstruct the track due to e-conversions and remove the background hits by implementing CapBoost. We expect the CapBoost to perform better accuracy of the model and remove almost a background in the CDC, and the timing of the training, the data should be fast as we expected. Next. Here is future work. Also, we need before we train, we need to do some analysis and validations, such as signal and background acceptance, timing, triggering, and tracking cards. And we also need to achieve the comet benchmarks to create a local features, neighbor features, and track features. And lastly, we implement the CapBoost algorithm to reconstruct the track due to e-conversions. Next. So here's the reference. Okay. Next. Okay, that's all. Thank you.
Thank you so much to Mr. Fahmi for his interesting presentation on the algorithm and simulation study. We really appreciate the contribution given. Next, I would like to invite our next speaker, which is Dr. Muhammad Nurul Ihsan Muhammad, to present his work on the analysis of modulated signals performance for the automatic radiographic window. Please welcome.
Dengar tak? Assalamualaikum and very good morning to all of you. Thank you, Mr. Chairman. Okey ke ni? Saya boleh terus ke macam mana? Hello?
Boleh.
Okay, the title of my paper is Analysis of Modulated Signals Performance for the Automatic Radiographic Winder. I'm representing my team research project that consists of Nuri Adila, me, myself, Nur Saleha, Mr. Yusni Sham, and Shatifi. Okay, as the next, please. As the introduction, actually, we are developing new generation of winder that going to be used in industrial radiographic testing to replace the conventional wire-based remote control winder. This study is under a project that fully funded by the MOSTI. Us that we need to develop the new generation of signal-based remote control. The new system that we are going to develop next, please, is this is the system that we have developed. Actually, the project consists of a few steps. This is the second generation of our winder that equipped with wireless remote control to increase the working distance, working condition from the gamma source while performing the industrial RT inspection. The problem with the current conventional winder is because it is a wire-based remote control, the length of the cable or the wire limit the distance that the operator or radiographer can be from the dangerous high energy ionizing radiation. I take, for example, if I use 10 curie of iridium-192, if you can see at the bottom, there is a scale from 0 to about 80 meter. For example, if I use 10 curie of iridium-192, I have to be at more than 50 meter of distance. Whereas the longest cable that available in the market now is only 15 meter. Actually, 15 meter is a bit too much because in our work we need to use mobile equipment. Normally, people only use about 5 meter of winder, which is very dangerous for the radiographer. So that's why we take this challenge, we take this responsibility to try to develop the new generation of winder that will make sure that the radiographer can work in a safer working environment. Next, please. So in our winder, we use modulated signal. We have considered two types of remote control system, which is Bluetooth and Wi-Fi. So in our daily life, I'm sure that we are very familiar with this kind of apparatus that use a wireless technology. For example, mouse, keyboard, TV remote, and maybe every one of us use daily the car remote control. So the main component in this kind of remote controller is only two components, which is the transmitter and the receiver. The transmitter also act as the controller, and the receiver. Actually, it is embedded this kind of tools. For example, if we use remote control for our car, the remote controller itself act as the transmitter, and in our car, embedded the processor they call maybe Arduino, Raspberry Pi, whatever suit the application, and also signal module connector. And also this kind of system need to be programmed. They use program codes that suit their needs. Next, please. The motivation of our work, our paper is because we are dealing with very high energy ionizing radiation, for example, iridium-192, and the system that we are going to develop potentially will be used in high industry applications such as aviation industry, power generation, and so on. So we have to make sure that our system must be able to operate, of course, to be operated at a required safe distance, because that are the main objective of this grant. And also, we have to make sure that the connection of our system must be stable enough, and we have to guarantee that it is stable. We don't want it to be like when we expose the ionizing radiation, we expose mean we take out the source, the gamma source outside the gamma projector, which is in this condition, the ionizing radiation is everywhere. So we don't want it to be in this kind of condition. When we expose it and we lost the connection or we lost the control of the source, this can be very dangerous. So we have to make sure that our connection must be stable enough to avoid this kind of situation. And also, the system must be safe enough, or in other words, must be secure. Because in normal practice, for example, we are working with in a plant. For example, in Petronas plant, oil refinery plant, for example, there are more than one team that performing the radiographic testing. So we don't want it to be like we try to expose our source, but it triggered the other source that can be very, very dangerous. So we must ensure that the system that going to be developed must meet this kind of criteria. Next, please. So in this study, we want to see the effective range or length of different type of remote control module at open space. Because in radiography inspection, it's either we work in open space or at closed space, or the space with the barrier like wall, pipeline, tank, and whatever obstacle. I mean, so the open space is the simplest or the simplest situation that we are considering in our paper. So we also want to finalize what is the best module that we can put in our system that we call it our final prototype P3. Next, please. So a little bit about the Bluetooth technology. It has been introduced in the early millennium with the version 1 and up to version 3 to 2009, something like that. All this version 1 from version 3, they call it the classic Bluetooth, which is the effective length is not far enough for many applications. We remember at that time the handphone that equipped with Bluetooth it's not as effective as the today's technology, Bluetooth technology. So starting from 2010, they have introduced the Bluetooth Low Energy or BLE, Bluetooth version 4.0. Up to now, they have the latest version is version 5.0. So in our study, we have considered 3 types of Bluetooth version. Next, please. First, we have HC05 represent the Bluetooth 2.0 or classic. It is Bluetooth 2.0 that represent the classic type of Bluetooth. Then we have a new generation of Bluetooth 4.1, which is better than 4.0, claim the effective range up to more than 200 meters. So we consider this Bluetooth 4.1, and the last one is Bluetooth 5.0, which is the latest technology of Bluetooth. And also we take one sample module sample of Wi-Fi ESP8266. All these 4 module has been next please. Has been installed with the Arduino board and 3 other components, which is buzzer, LED light, and the temperature sensor to make it become a complete system, and also controlled by, if you can remember, in the beginning, I said that there are 2 components of remote control, which is controller and the receiver. In our case, we use cat phone as the controller. So we have to put all this thing together. Next, please. In a circuit like this, and we have wrote a simple program and integrate this thing together to make sure that it's function as a remote control system. Next. After that, we have performed the pre-testing to make sure that our system works as we wish. So from this is the result of the pre-testing. From the preliminary study, we found that all 3 Bluetooth module or system work very well, as there is slight problem with the Wi-Fi system because the LED and buzzer, monitor communication, and pairing with the controller, all these features is not working as well as the other Bluetooth system. But it's okay, it still can be used to study the effective range of all these 4, especially for the Wi-Fi. Even though it's not function 100% well, but still can be used to study what is the effective range of the Wi-Fi system. Next, please. So in the methodology, because we want to know what is the effective range of all this system. So the first step is we put the controller and the receiver together, facing each other, and we activate it and see if the light, sound, and RSSI. RSSI means receive signal strength indicator. We see the signal strength indicator to see if we observe the RSSI to see how strong is the signal that we can receive from that particular distance. And then we repeat the step for about 5 times to make sure that every single time that we have tested, the system must be worked very well, because we don't want it. For example, if we try 100 times, we have to make sure it work 100 times. We don't want it 99. It's okay. One is not okay. So we consider at that distance, this system is not stable. So that's the way we do it. So then we move the transmitter or the controller 5 meters away from the receiver and repeat the first 2 3 steps. And then we move 5 more meters away with the interval of 5 meters. We repeat the experiment until the transmitter and the receiver cannot be communicate anymore. So that's at that particular distance, we can consider that that's the limit for the system. So we have repeated for all 4 modules that we have developed and see what is the result that we can get. Next, please. So next, please. Next. Okay, this is the result that we have obtained from our experiment. It is quite surprising because we expect that Bluetooth new version of Bluetooth, which is 4.1 and BLE 5.0, supposed to be better than the Bluetooth, the older version of Bluetooth, but it's a bit surprised that we found that Bluetooth 2.0 can be better than the newer version of Bluetooth. But in our case, the Wi-Fi system can work better than all the Bluetooth system that we have developed. So this is the result that we have obtained. Next, please. As the RSSI result, we also the result in negative dB value. So the below value is we can see better than the upper value. So in this case, we can see that Wi-Fi also seems better than all those Bluetooth system that we have developed. Next, please. So as the conclusion, we can see that these are the findings that we have received from the test, and also we can see that the ESP8266 actually, there is a typo here. This Wi-Fi module produces the highest efficiency and most suitable to be used in our system because it can be at the longer distance as compared to other 3 modules. So that's all. Next. That's all for my presentation today, and thank you very much for your time attention.
Right, thank you so much, Dr. Nurul Ihsan, for the exciting and interesting innovation on the winder. So really appreciate your contribution, and thank you so much. So ladies and gentlemen, before we move on to the next session of the day, which is session 8, so I'd like to remind you, before lunch break, we will have another code challenge, and please make sure all of you can join it because there will be some rewarding prizes for you, right? And today, also don't forget, just before the end of the conference, we will have the final nuclear debate between the universities for you to watch. So that's all for now. Hope you guys can stay until the end of the conference. Thank you very much.
Assalamualaikum and very good morning. Welcome to iNuSTEC 2020. So we are now at the sessions 8A with the themes materials and sustainability. Okay, my name is Rogama Binti Ramli. I will be the chairperson for these sessions. Okay, without further ado, I would like to call upon our first presenter, which is Encik Muhammad Fahmi Muhammad Yusuf from University Science Malaysia with the research title Potential Use of Polyvinyl Alcohol Gel Material as Mammography Phantoms for the Detections of Calcifications. Okay, Mr. Fahmi, the floor is yours now. So we are now at the
Okay, Assalamualaikum and good morning, everybody. So my name is Dr. Muhammad Fahmi Muhammad Yusof. I'm from the School of Health Science of University Science Malaysia. Okay, so I will be presenting my work with my graduate students entitled Potential Use of Polyvinyl Alcohol Gel Material as Mammography Phantom for the Detection of Calcification.
gel material as mammography.
Okay, next. Okay, so as we know, mammography has been recognized as common method for early detection for breast cancers, and this mammography can be divided into two categories, which is number one, the screening mammography, which conducted on healthy person as early detection of breast cancers. And another one is a diagnostic mammography, which offers better localization of cancerous cells. So usually we start with the screening, okay, just to check. It's like a medical checkup, and then when it is suspected to have some diagnostically diagnostic information on the cancers, so they will proceed for the diagnostic mammography. Okay, and then as we know, this mammography they use very low X-ray energies because of the features of because of the properties of the tissues being imaged, which is mainly soft tissues. Okay, and then next. Okay, next slide. Okay, so in mammography, the indication of cancer is basically through the appearance of what we call the calcification within the breast tissues. Okay, so the calcification is defined as the hardening of the breast tissue due to the deposition of calcium compounds. Okay, and then the pattern of this calcification would determine whether the classification of the cancer itself, whether it is a benign or a malignant. Okay, and then benign, that means it is just a tumor that is not spreading to other parts of the tissue, whereas the malignant is what we call the cancerous cells, which is it has the properties of metastasis of and spreading throughout the tissue volume and later to the other organs. Okay, and then the pattern of the calcification will determine between the benign and the risk of malignancies. Okay, next slide. And then in imaging, in medical physics specifically, the phantoms is a very useful tools for the purpose of quality control. So the phantom in medical physics is defined as the material that simulate the attenuation properties of the human soft tissue towards the ionizing radiation. Okay, and then it is often used as the dosimetric studies, especially for radiotherapy. And then for diagnostic imaging, it concerns on the quality assurance to determine the image quality and the effectiveness of the imaging modalities itself. So as you can see in the picture, we have several types of phantom for different imaging modalities. We have the CT phantom that is operated that is mainly used for CT scanning. So we have two types, the water-based and also the solid-based. And then we have over there the MRI phantom, the JZ phantom, specifically for nuclear imaging. and then the fluoroscopy imaging, specifically for real-time imaging. And the last one over there is the solid water phantom, which is very common for dosimetry work and quality assurance, as well as the calibration involving radiotherapy modalities. Okay, and then in many dosimetric protocols, water has been used as a standard phantom. And then, however, due to its liquidity and then the liquid properties mainly, and then the fusible of many dosimeters to be used within it, nowadays we can see that there's a lot of solid type phantoms that is used for quality assurance and as well as the dosimetry works in medical physics. Okay, next slide. So in mammography, the most common mammography phantom used is the mammography accreditation phantom model 18220 by the Fluke Biomedical. So I believe in many diagnostic radiology departments, especially those who have this mammography facility, they usually have at least one of these phantom. So this phantom has the feature of calcification, simulated by the aluminum oxide specs at various sizes. So as you can see from the picture being shown over there. So the first picture is the phantom itself. The second picture, the middle one, is the image. It's a schematic diagram of the image that should be visualized by the mammogram. And then the tables over there indicates the specification of the phantom. So there's about five clusters of calcification to be imaged. And then in the quality assurance of mammography, usually the modality needs to visualize all the specs of the calcification in order to be approved to be used or validly to be used for imaging. Okay, next slide. However, in many phantoms available for mammography, including all the previous works, they have several limitations because most of the phantom, they focus on the dosimetry works, such as the glandular dose and the image quality of the mammogram itself. And then another one, most of the material are made of acrylic and perspex that are solid and incompressible. Whereas the nature in mammography, usually we need to compress the breast tissue in order to have a better visualization of the calcification. Okay, and then unfortunately, many phantoms available, they are mainly solid and incompressible. So the compressing during the mammography have the advantage of better visualization of calcification as it extend by spreading them. So the compression would expand or spread the calcification within the tissue for better visualization of the mammogram. Okay, next slide. And then a little bit about the polyvinyl alcohol or PVA used in this study. So this study focused on the fabrication of a phantom made of the PVA gel material. So this material is a water-soluble and non-toxic synthetic polymer. And it will form a gel structure through the process of freezing and defrosting. And then it is widely used in plastic and fabric manufacturing, especially, and then it has the advantage of being reused. I mean, this material can be later being reused or being liquidified back, and then to be reshaped into other shapes and sizes. Okay, and then it has the gel property greatly influenced by the concentration of the PVA solution, because in our previous work indicated that the larger amount of the percentage of PVA inside the solution of PVA water would give better strength to the material itself. And it has the mass density of 1.19 gram centimeter cubic, which is close to the value of water, which is 1.0, as we know. And then And then the value also is near to the value of perspec that is mainly used for as phantom material in diagnostic imaging. And then previous study also indicated that it has a MRI parameter that is similar to the human soft tissue. Okay, next slide. So the advantage of PVA gel as phantom including it is a non-toxic synthetic polymer. That means it is safe to be used by the personnel. And then it has mass density close to the human soft tissue as mentioned earlier. And it can be fabricated at various shape and percentage of PVA without significantly modify its density. So that means if you put whether 10% or 50%, it will not significantly change the density. It will still equal to the value of water. Possible that simulate the physical problems. On our previous finding, also it has mass attenuation coefficient and tissue equivalent properties similar to water and the soft tissue, as we can see from the diagram being shown. First, of mass coefficient of the PVA material. So our finding found that it has a value very close to water, indicating its similar attenuation properties to water at low kilovoltage energy. Kilovoltage energy of X-rays. And then the second one is our previous work when we manufactured a bolus material, which is commonly used for radiotherapy. So the property of PVA as bolus indicate similarities to the standard bolus used in the radiotherapy. So these two findings indicated the similarity of properties or attenuation properties towards the PVA gel towards ionizing radiation. Okay, next slide. So as a methodology, the sample preparation is by mixing the PVA with water at percentage of 20% by heating method. So we heat the water along with the PVA powder, and then we make sure that all the PVA is soluble to the water, and then it is followed by the cooling down to eliminate the air bubbles, and then it is filled in a container of approximate of 5 to 7 centimeter, which is close to the dimension of a standard mammography phantom. And then it will followed by the freezing at approximately of 12 hours, and then followed by the defrosting to obtain the gel material. Okay, next. Okay, these are the phantoms that we fabricated in this study. So we fabricated 3 phantoms, the PVA gel phantom and then we label it as A, B, and C. Okay, next slide. So the difference is the depth of the calcification on each phantoms that we fabricated have different depth of calcification simulated by the calcium carbonate powders, and then we put it in 3 different simulated depths within the tissue. 3 different depth of 1.4, 2.6, and 3.6 centimeter from the surface of the phantom. Okay, next slide. So the mammography image are obtained by using a digital mammography unit in the radiology department of Hospital University Science Malaysia. And then the exposure factors used for this imaging is chosen by the automatic exposure control based on the compressing force and resultant thickness of the gel phantoms. So when the gel is being compressed, the amount of compression in Newton will determine the appropriate exposure factor of the image. Okay, next slide. So the images will be analyzed by using the images software because it is feasible. So our previous work also indicated the feasible feasibility of this imaging software to analyze radiography images. And then the calcification pattern are at different depth and exposure factors resulted by the compression is observed and analyzed. Okay, next slide. Okay, as a result, these are the exposure factors resulted from the compression of the fabricated gel phantom. And then we can see that the KVP would change when different amount of force of compression is exerted, because of when the force of compression increase, the thickness will be decreased, and that will increase the exposure factors. Because the compression would somehow increase the density of the material, therefore different KVP will be used to get the sufficient image. Okay, next. So as a result, these are the images obtained from the Phantom A, which is the calcification at 1.4 centimeter depth. Okay, the first one is when no force is applied. Second one is 22 until 159 Newton of force of compression. And we can see that there is no significant difference when different compression are applied to the formation of image or visualization of the calcification. Okay, next. The same goes to the Phantom B, which is 2.6 centimeter of calcification, 2.6 centimeter depth. Okay, so as we can see, similar to Phantom A, there is no significant difference. The image is clearly visible at all compression forces and also exposure factors. And then the shape of the calcification also doesn't significantly change. Okay, next. Same goes to the Phantom C, which has a deeper calcification at about 2.6 centimeter. So as we can see, similar to Phantom A and B, there is no significant change in the shape of the calcifications. There's no significant change of the visualization, the contrast, and also the image quality of the mammogram. Okay, next slide. And then, as the overall result, all calcification are clearly visualized at all compressing force of mammography, and there is no significant difference of the visualization at different compressing forces, and then there is no significant difference of visualization at different depth of the calcification. And then the PVA gel material can be fabricated as phantom at all calcification depth and exposure factors. And then there are also actually some limitation in this study. So these phantoms are actually our more like try and error. We supposed to visualize the calcification, the micro calcification. Okay, because in mammography, the crucial part in the detection of benign or malignancies is the micro calcification. So in this phantom, we're supposed to have what we call the micro calcification, which is smaller specks of calcium carbonate powders. However, in this study, it appears to be much larger than supposed to be micro calcification, and then so that's why we cannot do any scoring for the images. On the future, we probably will have to try to simulate the micro calcification and do the scoring of the images. Okay, next slide. Okay, as a conclusion, the fabricated gel phantom are able to visualize the calcification using the mammography imaging at all experimental compression forces and exposure factors. And then number two, the exposure factors used based on the phantom thickness resulted from the compression forces did not significantly affect the visualization of the calcification features. And then number three, the depth of calcification also did not significantly affect the visualization of the calcification feature. And then the overall result indicated that indicated the potential of a PVAL gel material to be developed as phantom for quality control of mammography imaging. Okay, next slide. Okay, so these are my references. So I would like to acknowledge the radiology department of HUSM for the use of mammography, and also the biophysics lab of the School of Physics, University of Science Malaysia. Okay, so by that I end my presentation, and I open for any question. Thank you.
Thank you, Dr. Fahmi, for your presentations. Okay, then I would like to call upon Ms. Franca Iwoja Oko for a presentation that titled Determining the Electric Properties of Polyvinyl Alcohol Composite as Suitable Material for Breast Strengthens. Okay, a comparative study. Then the floor is yours, Ms. Franca.
Okay, thank you very much, Madam Chairperson. My name is Franca Oimojahuko. From a PhD student of medical physics, University of Science Malaysia. My research is titled Determining the Elastic Properties of Polyvinyl Alcohol, PVAL composites as Suitable Materials for Breast Phantom, a comparative study. Other members of the research team include Dr. Modfami Modusuf, the immediate past presenter, Monaili Ahmad Kabir, and Siti Noor Aziza. The outline for my presentation include introduction, objectives, the methodology, the results and discussion, and then the conclusion. Next, please. Breast phantoms mimic breast tissues, like the previous presenter mentioned. It's a continuation of the same work. And then for any material to mimic the breast, it ought to possess the physical, mechanical, and radiological properties of the breast. Like you saw in the previous presentation, we already worked on the radiological properties, which include the linear and mass attenuation coefficient of PVAL, and we already also measured the CT number and other parameters. In this work, we considered measuring the density of the PVAL and the Young modulus, which measures the elasticity of the soft tissue. The breast density, according to the American College of Radiology, breast density has been classified into 4 major categories. That's the BIRAT classification. BIRAT A or 1 is the breast that is almost entirely fat. It constitutes 0 to 25% of fibroglandular tissue. Actually, this classification is based on the amount of adipose and fibroglandular tissue in the breast. The second category is the BIRAT 2 or B, which comprises of 50%, 25 to 50% fibroglandular tissue. Is popularly known as the 50-50 breast, and most commercial phantoms are fabricated to suit this 50-50 breast. The third one is the BIRAT category C, which is heterogeneously dense. It's composed of 25 to 50 to 75% fibroglandular tissue. And then lastly, we have BIRAT D, which is extremely dense breast tissue, and it is composed of 75 and above 75% fibroglandular tissue. The Young modulus is a parameter that measures the elasticity of soft tissues. That is the mechanical, that falls under the mechanical property of the breast. So like some of us may be aware, water is the #1 tissue equivalent material, but it is limited because of its liquid state. And because of the importance of compression in mammography, there is need to have a solid phantom that mimics the breast and not just a solid phantom, one which is compressible, because compression is critical in mammography. This is because compression improves the quality of the image, it reduces the dose, and then reduces the thickness of the breast, thereby and causing the breast tissue to spread out and making it easy for the lesions, either the calcification or the tumors, to be easily visible. And so the polyvinyl alcohol is an industrial compound that is commonly used to produce adhesives, can be used to produce food packaging, and commonly used for children's craft projects. This compound, an appropriate amount of this compound, when dissolved in water, can be used to produce a compressible semi-solid gel which possess tissue-making properties. Next slide, please. So the objective of our study is to fabricate a PVAL-based potential breast tissue equivalent phantom of various densities for mammography. And then secondly, is to investigate the young modules of the fabricated PVAL composite by puncture tests using the puncture and the texture analyzer. Next slide. Okay, the sample preparation. Sample preparation was carried out in the medical physics laboratory and School of Physics. The procedure includes, first of all, dissolving the appropriate amount of polyvinyl alcohol granules in deionized water at 90 degrees centigrade to obtain a clear solution of 10% PVAL. The solution is allowed to rest for 2 hours to cool and remove air bubbles so that we don't have air gaps inside of the phantom. The solution is then poured into plastic molds of height 20 millimeter and diameter 20 millimeter also. This solution is subjected to a freezing and thawing cycle. This means that we are put inside the freezer at a temperature of minus 20 degrees centigrade and allowed to freeze for 12 hours, after which the phantoms are brought out of the freezer and kept in the laboratory at room temperature and allowed to thaw, that means defrosting, for another 12 hours. This cycle of freezing for 12 hours and defrosting for 12 hours is known as, it's called one freezing and thawing cycle. So the number of freezing and thawing cycle that we subject a particular PVAL solution to determines the rigidity of the gel that will be obtained at the end of the day. So in this experiment, we subjected phantoms to separately to 1 and 2 freezing and thawing cycles so that we can have phantoms of different rigidity. And then secondly, ethanol solution was dissolved in PVAL to obtain another phantom type, and then graphite powder was also dissolved in PVAL to obtain yet another type of phantom. And so in all, we had 3 different types of phantom to mimic different densities, different breast densities. So we had PVALE, the one that contains ethanol. We had PVALG, the one that contains graphite powder. And then we have PVAL, water-based PVAL. Next slide, please. So this is the setup for the preparation. The figure A is the setup for preparing the PVAL solution. That is the process of dissolving the granules in the ionized water. Figure 2 shows the clear PVAL solution that was obtained after the first process. And then figure 3 shows the PVAL sample, the test samples that were obtained from the 3 different sets of solution that we prepared. The black one is a PVAL that contains graphite, and then the middle column, which is kind of opaque in color, is a PVAL that is just water-based. And then the last column, the column to the right, is the transparent sample, is the PVAL that contains ethanol solution. Next slide, please. Physical and mechanical testing of gel samples. The mass density of each sample was calculated as a ratio of mass to volume. We measure the mass of each test sample with the electronic scale. and then the volume was determined by displacement method, which is based on Archimedes principle. The mechanical properties of the PVAL composites were studied through the puncture test. Specifically, the Young modulus was evaluated. So the puncture test was carried out using the texture analyzer with a 5 kg load cell, as shown in Figure 4. Figure 4 is on the next slide. Samples. So the sample was placed on the mechanical testing machine, and the force was applied. The aluminium probe was compressed into the sample to a penetration depth of 8 mm at cross-head speed of 0.5 mm per second. The measurement was carried out on the PVAL, the PVALE, and the PVALG samples that underwent 1 and 2 freezing and thawing cycles. So at the end of the experiment, the force distance data was collected from the texture analyzer system, and the Young modulus calculated using their mean values based on equation 1. Next slide, please. So this is the setup for performing the experiment. You can see the sample placed on the texture analyzer, and then the aluminium probe, which is driven into the sample during the experiment. So the depth, the distance of it, the time taken to for the probe to penetrate a distance of 8 mm depends on the rigidity of the sample. Next slide, please. Young modulus is evaluated using equation 1. The Young modulus is given by sigma, which is a stress, sigma E, where sigma is force per unit area, and epsilon is the strain, which is the L over L, change in length. Next slide, please. Results and discussion. So as you can see, this is the result of the density, the calculated density using the bathymetric method. The PVAL had a density of 1.05. PVALE had recorded the least density of 0.962, while PVALG recorded the highest density of 1.081. So we can see that all the densities recorded are close to the density of water, which is 1.0 gram per cm3, and also we are close to the density of breast tissue, which is 1.02 gram per cm3. So the closeness of the mass density of these test samples to the density of water and breast tissue suggests that the samples possess water and tissue equivalent properties. And secondly, the PVALE, the PVAL, and the PVALG could be used to mimic the RATS category B, C, and D. Like I mentioned earlier, category B is a 50-50 breast. Category C is the one that contains up to 75% fibroglandular tissue, while the category D is the one that is extremely dense. So we could use this to mimic these categories of breast tissue based on their density, on their mass densities. Next slide, please. And this is the result of the Young modulus. From figure 5a, the calculated Young modulus of PVAL, the one that PVAL with one freezing and thawing cycle recorded the least Young modulus, while the PVAL with the 2 freezing and thawing cycle recorded the highest Young modulus. This is the stiffness, the sample stiffness and applied force increased with increasing number of freezing and thawing cycles. The results confirms the linear relationship that exists between the Young modulus and the force. So the summary table here shows the result obtained from our study, the range of Young modulus obtained from all the samples studied and previous studies. As we can see, our result, there's a lot of disparity in the result, in the values of Young modulus obtained by different studies. This could be attributed to the technique used, different techniques used in measurements. The measurements are quite different, and then the sample geometry, and then again the amount of strain applied during the experiments. Next slide. So the observed disparity could be associated with variation in strain levels used by different authors, inconsistent sample geometry, and different measurement methods. Differences in young modules of calculated tissues can span an extremely large dynamic range of elasticities. So even with large errors, differential diagnosis based on elasticity imaging may still be useful. But the result of this study indicates that all the gel samples studied could simulate different categories of breast tissue based on their density. Next. Okay. And in conclusion, the density of the fabricated PVAL gel phantoms showed close resemblance to those of water and breast tissue based on AMPM and ICRU44 reports. The results of young modules indicate that the fabricated PVAL composite phantoms examined could be used to simulate breast tissue. Thank you very much.
Thank you, Ms. Franca, for your presentation. Then we will move to our third presenter, which is Ms. Nur Fatin Amira Shafi, with the research title Determining the Effects of 2-dimethylamino ethyl methacrylates concentration on thermosensitive nanogel size. The floor is yours now, Nur Fatin. You may start.
Okay, thank you to the presenter. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nafati Amir bin Shafi'i, and today I will present the influence of 2-dimethylamino ethyl methyl acrylate (DMAEMA) concentration on the thermosensitive nanogel size. Next slide, please. Okay. As for the research background, from the newspaper feed, we can see that cancer is a leading health issue facing men. So, according to World Health Organization, cancer is a severe life-threatening condition around the world. And in 2017 alone, around 9.6 million deaths annually has been detected, and 18.1 million newly identified cases every year. Closer to home, as you can see from the newspaper feed, high cancer case and late stage diagnosis worrying, says Director General, and also more Malaysian diagnosis with cancer than ever before. This is in January 2020. And in Malaysia, around 37,000 newly diagnosed cancer cases yearly, and foreseen to be escalate beyond 55,000 cases by the year of 2030. Concerning the aim of addressing the government high spending on imported drugs and treatment costs, a development of effective and great performance drug delivery system is crucial. Targeted drug delivery may provide a more efficient and less harmful solution to overcome the limitation found in conventional strategies. Temperature responsive nanogels are considered to be effective in overcoming the limitation of premature and insufficient drug release at target sites in drug delivery system. Next slide, please. Temperature responsive nanogel, also known as thermosensitive nanogel, is a nanogel that responds to change of temperature with a phase transition and cause the release of encapsulated cargo. NIPAM, the long name is N-isopropyl acrylamide, is one of the best non-thermosensitive polymer known today. As you can see from the picture, the LCST of NIPAM is 32 degrees Celsius. Below 32 degrees Celsius, the NIPAM is swelling and act as a drug-loaded nanocarrier. And above 32 degrees Celsius, the NIPAM will shrink and will release the drug. Tumor tissue that tumor tissues that undergo high growth rate and rapid metabolism differ from normal tissue. The temperature for tumor tissue is around 40 degrees Celsius, while our normal tissues temperature is around 36 to 37. So, the LCSD of NIPEN need to be higher than 37 degrees Celsius to detect the cancer cell. The LCSD of NIPEN that is below 37 degrees Celsius restrict the application in tumor-targeted drug delivery as they would precipitate once introduced into human body and lost thermal targeting function. Okay, next slide, please. Next slide. For the research methodology, as you can see, for nanogel, synthesis of nanogel will be NIPEM and will be copolymerized with other materials such as PEGDA, which is polyethylene glycol diacrylate, PVP, polyvinyl pyrrolidone, and also the MAAMA, which is 2-dimethyl amino acid. The PEGDA and PVP will provide stealth properties to this nanogel, and the DMAMA will strengthen the thermosensitivity of nanogel, which will increase the temperature, the LCST. We are using the gamma radiation induced polymerization method because no addition of harmful chemical and initiators and also no cross-linker. It is also a free radical copolymerization. The dosage for the gamma radiation is actually 5, 10, 15, 20, and 25. And after that is the characterization and testing of an NPPD nanogel using DLS, dynamic light scattering, and also zeta potential. As you can see from the table, the concentration of DMAMA for sample B, C, and D is increasing, and sample A act as the control sample. Next slide, please. DLS or dynamic light scattering is used in the study as the CST of NPPD nanogel can be studied using the DLS where the sudden drop of size can be observed. As you can see, there are a decline in size of nanogel. This shows that there are a temperature contribute in swelling of nanogel. And after 25 degrees Celsius, errors at higher dosage is shown, which is attribute to aggregation of nanogel. For control sample, sample A, the range of size is 22 to 201 nanometer, while the size for NPPD nanogel, sample B, C, and D is 221 to 3000 nanometer. According to Hamzah et al., the ideal size for nanogel in drug delivery application is 70 to 200 nanometer, and if it's increased above 200 nanometer, the nanogel will opsonize. The opsonization will result. The opsonization will result in accumulation in liver and spleen, which lead to a higher risk of aggregation. Okay, next slide, please. One essential parameter used to foresee stability in this research is using the zeta potential. As indicated in the figure, zeta potential increase with dosage for control sample. The zeta potential value in the radiation dose range demonstrate a maximum stability of 6.05 MV, at which the dosage where the nanogel start to form small aggregate with the highest value of collective surface charge density. At higher NPPD nanogel, sample B, C, and D, the The zeta potential decreased, showing that the effect of collective surface charge was overcome by the increased size of nanogel. Overall, zeta potential values were lower than control sample. This could be due to the steric stabilization of DMA-AMA upon combination of the nanogel. Next slide, please. So, as the conclusion, a series of MPPD, NIPEM, PVP, PEGDA, and DMA-AMA nanogel were designed and prepared. However, DMA-AMA has concluded to interrupt the formation of nanogel and shrinkage at similar formulation. So, for the recommendation, hypothetically, the encouraging temperature sensitive property of the MAMA is a promising material system and have a great potential in drug delivery system. Hence, such alteration would be favorable for extensively studying the importance of this promising DMA-AMA based on system towards successfully drug carriers. And besides that, we also could do add another characterization and testing using other instruments such as FTIR, CEM, SEM, UVVs, and also HNMR. Next slide, please. So this is the reference for my presentation, and that's all from me. Thank you.
Thank you, Ms. Novatin, for your presentations. Then I would like to call upon our fourth presenter, which is Ms. Esther Philip, with the research title, Evaluations of Radium and Cesium Containment Performance of Palm Oil Fuel Ash, BOFL, Supplemented Cementitious Backfill for Borehole Disposal, Kinematic Investigations. Ms. Esther, the floor is yours now.
Thank you, Madam Chairman. A very good morning, ladies and gentlemen. Thank you for joining this session with me. First of all, I would like to introduce myself. My name is Esther Philip from Nuclear Malaysia. Today, I would like to share with you my current research on the application of palm oil fuel ash supplemented cement as engineered barrier in a radioactive waste borehole disposal facility. So for this session, I will be sharing on the evaluation of radium and cesium containment performance of the palm oil fuel ash supplemented cementitious backfill for borehole disposal from the kinetic point of view. In my presentation today, next slide please. In my presentation today, first of all, I will introduce you to disused seal radioactive sources, which is a type of waste that we are considering to dispose in a borehole type facility. I will also talk about POFA or palm oil fuel ash as partial replacement for cement. And I will also share with you the objective of this research as well as the experimental approaches and also the findings. Next slide, please. One of the last talk about radioactive waste is disused seal radioactive sources, or known as DSRS. DSRS are commonly found in smoke detectors, lightning arresters, teletherapy, and brachytherapy units, as shown in the slide. These small metallic things that you can see in the slide are actually the seal sources that are being implanted inside the smoke detectors, lightning arresters, teletherapy, and brachytherapy units. DSRS contain a wide range of radionuclides, commonly including americium, cobalt-60, cesium, radium, strontium, just to name a few. So in our waste inventory in Malaysia, the two major sources comes from cesium-137 with half-life of approximately 30 years, and also radium-226 with a very long half-life, about 1,600 years. Next slide, please. A borehole disposal concept has been considered for the disposal of these DSRS. Shown here is the schematic diagram of borehole disposal concept as recommended by the IAEA. So this borehole disposal concept adopts the multi-barrier system that consists of geological barrier as well as engineered barrier. Backfill is one of the elements in an engineered barrier. Basically, the safety functions provided by the backfill is the retardation of the migration and eventually the release of the radionuclides contaminants by means of containment of the radionuclides inside the backfill. So how does the containment achieve? Well, it is achieved by sorption mechanism that involves the binding of radionuclide contaminants to the backfill material. For boral disposal, it is recommended to use cementitious material as the backfill, like in many other disposal concepts. So what is cementitious material? Next slide, please. So why is cementitious material being widely used in radioactive waste management, especially in disposal activities? Cement in particular has high sorptivity for metals and radionuclides alike. The alkaline environment presented by the cement prevents dissolution of the ions and therefore resulting in less mobility of the ions. Other than that, cement is also able to provide desirable physical and mechanical properties based on certain specific application. As much as there are tons of benefits that can be reaped from cement, nevertheless, the major drawback of cement is the conventional cement production that release greenhouse gases, especially carbon dioxide. So one of the efforts taken is by partially replacing the cement with supplementary cementitious materials that always in the research originated from waste from other industries. For example, silica fume, fly ash, and also POFA. So POFA is a byproduct from palm oil mill processing industry obtained from the burning of palm oil biomass. So being a waste itself, POFA can be seen dumped at the mill site, causing environmental hazard, especially dust to the surrounding areas. POFA cement is actually very widely investigated for its purpose in the construction industry as an approach towards promoting environmental sustainability. Therefore, our study is also an effort towards supporting not only the environmental sustainability of the cement and concrete industry, but also to the radioactive waste management by utilizing local byproducts waste that are easily accessible. Next slide, please. So the objective of this study is actually, the main objective is to investigate the containment of radium and cesium by POFA supplemented cementitious backfill material and compare it to the ordinary Portland cement, especially type 1 that is always has always been used in a radioactive waste disposal facility. So in this presentation today, however, I will only talk about the outcome of the kinetic investigation. Next slide, please. In terms of experimental, so the core materials used in this study are ordinary Portland cement type 1 and also POFA. The POFA was obtained from a palm oil mill in Banting, Selangor. The raw POFA was subjected to a series of drying, heat treatment, grinding, and sieving to obtain the fine POFA used as supplementary cementitious material in the study. So for the kinetic study, optimized POFA cement formulated from 70% of OPC and 30% of fine POFA with water to cement ratio of about 0.4 was used. First of all, cement cubes were produced and followed by crushing and grinding to obtain powdered form of less than 250 micron. For this sample, active samples radium-226 and cesium-134 as analog for cesium-137 were used. The radionuclide solutions were prepared using cement for water. Next slide, please. So the sorption experiment was carried out by the normal batch method, in which the powdered cement sample was mixed and agitated with the radionuclide solution at different duration. The radioactivity of the samples was analyzed using a gamma spectrometer, and the sorption capacity was calculated based on this equation shown here. So the details in the calculation can be found in the full paper. So next, please. So the findings for this study, here I will summarize it into three main parts: the effect of contact time on the sorption capacity, the determination of reaction rates, and finally the determination of controlling sorption mechanisms. First of all, we can, as we can see the slide here, the content of silica in POFA is so much higher compared to OPC. So silica in any research has the ability to interact, to contribute to the binding with metal and radionuclide ions. Next slide, please. Okay, as you can see from the graphs here, it is obvious that desorption capacity for both cesium and radium by POFA cement, okay, with the red color, is higher than Portland cement. The higher absorption was due to the binding of cesium or radium to extra calcium silicate hydrate phases from the pozzolanic reaction. So calcium silicate hydrate is actually the most important phase in cement for binding of ions. It is also due, the higher absorption is also due to the absorption of cesium or radium by free silica oxide from the POFA itself. So cesium achieves equilibrium faster than radium. However, absorption preference for radium is higher than cesium. Next slide, please. So for the determination of reaction rates, the kinetic data was treated using 3 different models: pseudo first order model, pseudo second order model, and Ilovic's model. So findings shows that the kinetic data is not well fitted using the pseudo first order model. This model can predict the absorption process only at the beginning, but not for the entire absorption process. And a pseudo second order fits the data accurately, as shown by the high correlation factors, as you can see from the graphs here, the straight line. In fact, the experimental absorption values were similar with the values calculated from the model. Even though the absorption capacity was higher for POFA cement, the reaction rate was faster for OPC cement. The findings therefore suggest that the absorption basically involves a chemisorption process. Ilovic's model further supported the pseudo second order model, suggesting reaction rates that increase exponentially with the absorption, which implies a multi-layer absorption. Next slide, please. Okay, for the determination of controlling absorption mechanisms, the kinetic data was treated using 3 different models, which is intraparticle diffusion model, Bangham's model, and Boyd's model. The intraparticle diffusion model graphs here, as you can see from the graphs here, they show multi-linear plots instead of a single plot that runs through the origin. So this trend suggests that the absorption process is controlled by multiple mechanisms instead of one particular mechanism. So the absorption process is not only controlled by pore diffusion, but also might be controlled by film diffusion. So the decreasing of the diffusion rates constants suggests the diminishing role of the intraparticle diffusion and the increasing role of other mechanisms. Outcome from Bangham's diffusion model indicates that the absorption mechanism was not limited to pore diffusion alone, but also include other mechanisms. This is similar with the findings with the outcome from the intraparticle diffusion model. And then the outcome from the intraparticle diffusion model was further analyzed using Boyd's film diffusion model to determine the actual rate limiting step that involved in the absorption process. So the findings from the calculation from the models reveal that rate limiting step for the absorption process is governed by film diffusion or chemical reaction. Next slide, please. So the conclusion that can be made from the findings are listed here. The first one, the absorption equilibrium was actually faster for cesium compared to radium, which means that the interaction, the binding is much faster, for cesium compared to radium. And then the higher absorption for radium, absorption of radium was higher compared to cesium using both backfill materials, whether it's the POFA cement or the Portland cement. Higher absorption of radium and cesium by POFA backfill compared to the ordinary Portland cement. The pseudo second order described best the absorption process, suggesting that chemisorption as the main mechanism. In addition, the values of the absorption capacity from the experiment is similar to the values obtained by calculation from the models. So intraparticle diffusion models Begum's model and Boyd's model also suggest that pore diffusion mechanism is not the only rate limiting step that control the sorption process. There are other sorption mechanisms that are also involved. Next, please. So I think with that, I end my presentation. Thank you.
Okay, thank you, Ms. Esther, for your presentation. Then I would like to call upon our fifth presentation, okay, which is Ms. Tengku Sarah binti Tengku Amran with the presentation title NDT Method in Inspecting Road and Highway Structures. Tengku Sarah, the floor is yours now.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Sarah Tengku Amran. I'm from NDT MSI Group, Technology Industrial Division from Agensi Nuclear Malaysia. And today I would like to present about NDT method in inspecting road and highway structure. Next slide, please. Okay, so why we must inspect our road and highway structure? There are many reasons for performing the inspection. One of the reasons is for highway improvement with efficient maintenance. Because in order for us to do the maintenance, first we must know the condition of the highway or road structure. If there appear to be any damage, we must know how severe is the damage for us to take the preventive measure. Another reason is for economic development and also to enhance our life convenience. And lastly, the most important reason is for our safety purposes. If we have a damaged road or highway, we will put our safety at risk. So here, we also can see how much budget our government have allocated in order to repair our damaged road or highway. On the left side, 4 million a year to repair a damaged road. And on the right side, we can see 28 million to repair a collapsed highway. So all of this cause a great loss to the country. Next slide, please. So here is the example of the road and highway damage that we can normally see in our daily life. There have been cracks on the pavement. Suddenly in the middle of the road, there have been a hole appear out of nowhere. And sometimes you can see a tree can grow from that hole, as you can see in this figure. Next slide, please. Next slide. Is that if sinkhole suddenly happen, sinkhole is something that we cannot see with our naked eyes, or we can expect it to happen. Cases happen in Malaysia, and the most viral cases that happened last year, 19, whereas a woman in yellow Myvi car was swallowed by the sinkhole in the middle of Kuala Lumpur. How can we ever predict such accident can happen in Kuala Lumpur? Next slide. So Albert Einstein has quote, "A clever person solves a problem, a wise person avoid it." Hence, prevention is always better than cure. That is why we must inspect our road and highway structure regularly in order to prevent all the damage or sinkhole accident from happen. If the damage is meant to be happen, at least by inspection, we hope we can manage to reduce the severity of the damage. Next slide, please. So how we want to inspect our road and highway structure is by using non-destructive testing, NDT method. So why NDT method? It is used to evaluate structure without causing any damage and this test method can determine the quality and safety of the road structure more accurately and faster without incurring high costs. So what is the NDT method that we can use in inspecting road and highway structure? The most common technique is by using visual inspection. It is a technique that not using any equipment and less cost. So we have another technique, for example, ground penetrating radar technique, acoustic method technique, electrical method, nuclear technique, and also non-nuclear technique. Next slide, please. In order to produce a good result, single NDT method cannot determine the overall result. It must consist of combination of NDT method. Because all the NDT method have their own purposes and advantages in their own respective areas of expertise. For example, here we can see that in order to inspect the road condition, many techniques was involved. For example, electrical resistivity, impact echo, ground penetrating radar GPR, and also nuclear density gauge. Next slide, please. Okay, so here, for this presentation, I will talk only about these two NDT method technique, where the first one, I will talk about nuclear technique, nuclear density gauge, NDG, and for the non-nuclear technique, I will talk about ground penetrating radar, or we known as GPR. So for nuclear density gauge, NDG, it is a technique for soil testing where it used to measure the density and moisture content. And this device have two sources. First one is gamma source and the second one is neutron source, where gamma is from cesium-137 and neutron is from americium beryllium-241, where gamma used to measure the density and neutron is used to measure the moisture. And NDG are typically operated in one of two modes, which are backscatter and direct transmission mode. And for ground penetrating radar, it is used to detect and locate the subsurface object and mapping subsurface structure. This device uses electromagnetic wave, and the electromagnetic wave transmit at frequency between 100 MHz up to 2000 MHz. And the principle of using GPR is higher frequency will produce smaller wavelength and give a shallower depth penetration, and vice versa. Next slide, please. Okay, for NDG, the purpose of using NDG in inspecting road and highway structure is it is used to determine the compaction acceptance of earthwork, granular and stabilized pavement material and asphalt. This device ensures the pavement is constructed properly, where it will extend the service life of the pavement. Here we can see the general layer structure of a pavement. Usually it will consist of many layers, for example as surface layer, binder layer, base layer, and etc. So for each layer, NDG will do the soil testing to measure the density and moisture content. Where at the specified compaction level, follow the standard. So NDG offer a simplicity of performance, will give a rapid result and non-disruptiveness. Next slide, please. So how to use NDG for inspection method? As I said before, there have been two modes to operate the NDG. The first one is backscatter and the second one is direct transmission. The major difference between these two techniques is that for direct transmission, the source rod will be lowered into the mat through a pre-drilled hole where the cesium-137 source will radiate and will be detected by the detector. And for the moisture detection, it will only operate at backscatter mode. Next slide, please. So here is the example of the data acquisition of NDG, where here directly by using NDG, we will get the in situ density and moisture measurement. as it will appear at the screen of the NDG, the value of density and moisture. Next slide, please. Okay, now we will talk about ground penetrating radar. Okay, the purpose of using ground penetrating radar GPR in inspecting road and highway structure is that GPR has been used to measure layer thickness, to detect subsurface defect, to evaluate best cost quality. And for quality control survey, GPR technique have been used for thickness measurement, to estimate air void content of asphalt surface, and to detect mixed segregation. GPR is an effective tool for quickly determine the pavement layer at high speed without using any labor-intensive method such as coring. So here we can see that the result of the GPR is in terms of radargram image. Radargram image is the figure here with black and white color, where here it will directly show the result of the road surface, binder, coarse bottom layer, and etc. Next slide, please. Okay, so how to use GPR for inspection method? Usually, when we want to use GPR, we just push the GPR card by pushing the card and do the scanning on the pavement. And also, we have to do the point survey for GPR in order to make sure we manage to do all the mapping area. And another technique is just by attach the GPR at the vehicle for road inspection, where this technique will collect the pavement layer thickness data quickly, and it will eliminate the need for lane closure and will provide a safer working environment. But both techniques will give the in situ data measurement. Next slide, please. Okay, here is the example of the data acquisition of GPR, where here is the example of the case study that we have done before for highway inspection. Here, from the radargram image, we managed to find many anomalies pattern that we managed to categorize it into 5 profiles, which is the normal profile, the contaminated profile, the disturbed profile, the displaced profile, and reinforcement concrete structure profile. And usually for a sinkhole to happen, it will show a disturbed profile. Disturbed profile means a condition whereby the layer has lost its continuity due to the physical disturbance or modification, such as previous maintenance work or the existence of air void structure. Next slide, please. So for the conclusion, non-destructive testing can increase the effectiveness of road and highway quality inspection and verification to extend the lifespan of road and highway in Malaysia. And the second one is the two entity technique that we have discussed before, NDG and GPR, have their own purposes and advantages in their respective area of expertise. And the third one, periodic road inspection using entity be used as a method of self-testing of road and highway in the country, as this test method can determine the quality and safety of road structure more accurately and faster without incurring high costs. Next slide. That's all from me. Thank you.
Okay, thank you, Tengku Sarah, for your presentation. Then I would like to call upon our last presenter for this session, which is Miss Adila Hanin binti Aminuddin Sabri, with the research title Calculations of Attenuation Parameter for Iridium-192 Gamma Source in Shielding Materials. Miss Adila, the floor is yours.
Thank you to the chairman. Assalamualaikum and good afternoon. My name is Adila Hanim binti Aminuddin Sabri from School of Medical Imaging, University Sultan Zainal Abidin. My presentation today entitled Calculation of Attenuation Parameter for Iridium-192 Gamma Source in Shielding Materials. Next. So here is an overview of my presentations, including methods, results, and also the conclusions. Next, please. Next. Calculation of photon attenuation is indispensable in designing and irradiation facilities shielding. For example, lead material and ordinary concrete in the order of millimeter and centimeter thickness, respectively, had been widely used to attenuate the photons, either used as a shielding material for the wall thickness of an irradiation facility room, or to shield the emission of photons from a gamma source in a source peak. So the development and properties of non-lead and non-concrete material as a radiation shielding material have been studied previously by many researchers. Lead material, already known for its toxicity, expense, and limitation in abundance. For example, Olucotton proposed the use of clay and kaolin as an effective shielding material for photons. Then, Tabak studied carbohydrate-based compounds as new shielding materials for gamma radiation shielding. And then Akut and Kanaki dropped the clay with boron as a shielding material for higher energy gamma sources. Next, please. For the methods, the primary concern in many cases of photon shielding studied was for the transmitted photons, both scattered and also unscattered photons that penetrate the shielding materials. It was depends on the point at which the quantity of interest will be calculated or measured from the attenuating material. As example, there was a research that had been studied that the attenuation properties for the selected germanate glasses based shielding compound through theoretical calculation. In addition to attenuation coefficient and its related parameters, it is necessary to evaluate intensity transmitted or reflected due to the shielding material, particularly for a newly developed shielding material and photon energy in keV, as we need to ensure the radiation dose rate is low as possible as per background radiation, such as is important when designing a radiation shielding facility or for source storage. Thus, we conduct the study of our relatively new developed clay and fabricated clay polyethylene as well as ordinary concrete as a standard shielding material for high energy gamma source, which is iridium-192. So in this study, the transmitted photons of an ordinary concrete, clay, and fabricated clay polyethylene materials were evaluated by Monte Carlo simulation, which is EGS5 code. And then the transmitted photon using clay and fabricated clay polyethylene materials then were evaluated for gamma ray of high energy source such as iridium-192. So for the 13 energy distributions modeled in Monte Carlo codes ranging from 10.4 keV until 612 keV photons. Then the simulated linear attenuation coefficients from Monte Carlo calculation were compared to the values from XCOM database in order to get the value of discrepancies. Next, please. Okay, this figure, which is figure 1, shows the calculation of transmitted photons as a function of ordinary concrete thickness for a pencil beam of 380 keV incident photon. So here, it has to be noted that Compton scattered photons that penetrate the clay shielding material were ignored in our calculation for comparison with the attenuation coefficients generated by EXCOM database. And then the full square points were fitted with an exponential function to obtain the linear attenuation coefficient values of 0.228 centimeter to the minus 1. And then the calculated linear attenuation coefficient value has agreed with the theory within 0.44% to justify the subsequent calculations for multi-gamma source. Next, please. So for calculated for transmitted photons for multi-energy gamma source, previously in our study entitled Feasibility of Clay Shielding Material for Low Energy Photons, clay had been successfully demonstrated to decrease transmitted photon compared to ordinary concrete for low incident photon energy because of dominant photoelectric absorption. So a pencil beam of photons then was incident to the center of cylinder clay. Then the photon interactions such as pair production, Compton scattering, also including the Rayleigh scattering and photoelectric absorption were considered in our calculation. The linear attenuation coefficient value was calculated for multi-energy gamma source of iridium-192, and then the branching ratio of the gamma source was sampled according to JRIA data book. The table 2 shows the gamma energies and its corresponding branching ratio adopted in the calculation. Next, please. Okay, figure 2A, 2B, and 2C shows the calculation of transmitted photons as a function of material thickness, which is ordinary concrete, clay, and also fabricated clay, respectively, for a pencil beam of iridium-192 gamma source. So in figure 2, the full square points were fitted with an exponential function to obtain linear attenuation coefficient values for each shielding materials, while the calculated values by EGS5 is for iridium-192. The EXCOM values were obtained for a single photon energy of 380 keV. According to a study conducted by Richardson, 380 keV photon could be used as an average energy of iridium-192 gamma source. And then the next. Next slide, please. For the result of thickness, from the figure 8 until C, a thickness of 10 cm is adequate to attenuate up to 91% of the photons from iridium-192 source for ordinary concrete. But for clay and fabricated clay, 87% and 89% for our clay and fabricated clay respectively. So among these three materials, ordinary concrete is the highest value of attenuation because of a higher density compared to clay and fabricated clay, which is 2.302 gram per centimeter cubic. Then the attenuation value decreases as density decreases, where density of fabricated clay is 2.03 gram per centimeter cubic with attenuation of 89%, while density of clay is 1.99 gram per centimeter cubic with attenuation of 87%. Next, please. Okay, for the result of linear attenuation coefficient from the table, the calculated values of linear attenuation coefficient for the three shielding materials is consistently higher, about 7.5% than the ESCOM value for the 380 keV photon, and the higher calculated value by EGS5 was expected as iridium-192 gamma source was also consist a few percent of low photon energies as shown in table 2 before, and which are not considered in the theoretical value. So the ESCOM value is outputted from a single photon energy of 380 keV. Therefore, one who have no facility to do experiment or perform the Monte Carlo simulation could simply use the ESCOM database to estimate the shielding attenuation parameter with a few percent different in the case of multi-energy gamma source. And the ESCOM, and as the ESCOM database is only for a single photon energy, the use for gamma sources need to be verified either by experiments or simulations, as the particular gamma source might have lower and higher energy photons that need to be considered. Next, please. So, in conclusion to my presentation today, an approach of calculations for photon, either it is transmitted or reflected, one must be considered, particularly in exploring new elements or compound materials when designing radiation shielding. So, to our developed clays and ordinary concrete were calculated for their transmitted photons for a multi-energy gamma source such as iridium-192. Then, a thickness of 10 cm is adequate to allow transmitted photons up to 9% of the photons from iridium-192 sources, while 13 and 11% for clay and fabricated clay polyethylene, respectively. So the ordinary concrete linear attenuation coefficient value is higher within 15.5% and 7.25% compared to clay and fabricated clay polyethylene, respectively, due to higher density. However, the clay materials will offer lighter weight than ordinary concrete for similar photon attenuation values. So the use of ESCOM database is possible to estimate photon attenuation parameter of multi-energy gamma source by using an average gamma energy, which is 380 keV with to accept a few percent of difference. Then, as a sample, the calculated values of linear attenuation coefficient for the three shielding materials of iridium-192 gamma source is consistently higher, about 7% than the ESCOM values for 380 keV photons. Next, please. This is a list of my references for my presentation, and that's all from me. Thank you for your attention, and also many thanks to the iNuSTEC committee.
Okay, thank you, Ms. Adila, for your presentations. Okay, with this, we have reached our session for this morning. Continue with our Kahoot challenge. So please find our Kahoot challenge. Okay, there are prizes that waiting for you guys. Okay, for Kahoot challenge, our code is 2231105. Okay, we will start our Kahoot in any minutes. Okay, so please open your Kahoot now. We are waiting for you guys. Okay, so our code is 2231105. Okay, so thank you.
And I'm Ira, and my poster is on Gigamolar detector dataset for simulation of radioactive source localization algorithm. So whenever we have a new system that involves radiation detection and measurement, the best way to evaluate our system is to expose our detector with radiation or radioactive sources with intensity that covers the range of minimum to maximum of our target specification. Similarly, if we have the data set during our development stage, we can test our design and correct or identify any error and correct the bug before we do or proceed to the hardware implementation. Therefore, the objective of our research is to establish a method to generate the detector dataset based on the source intensity, the sampling geometry, and also the detector specification. So this is how we achieve our objective. First, we model the radiation measurement by gigamolar tube detector. So here is the simplified geometry. We have gigamolar tube and then we have radioactive source emitting the radiation. And by using equation 1, we can compute what is the expected intensity detected or measured by this gigamolar tube. And then by using the value as lambda, the expected intensity as the lambda, we can generate set of data by using Poisson probability distribution. And finally, we add on Gaussian noise to model the system signal noise. And this is the complete flow chart of our method. First, we define the sampling geometry. In our case, this is the geometry of our radioactive source localization algorithm. We have a total of 8 sampling points, and inside here is our region of interest, and the hotspot or the source will be located somewhere inside the region of interest. And we compute the expected counts for each sampling points. And for each sampling points, we generate independent data set by using the Poisson Poisson probability distribution. We add on the Gaussian noise, and finally we create the detector measurement vector data set. Here is our result. So this is the plots of data at sampling point 1, 2 until sampling point 8. And we use this data set as input to simulate our radioactive source localization algorithm. Here, initially, we don't know where is the position of the hotspot. And by using the data set, the algorithm has managed to pinpoint the location of the hotspot. And in other simulation, we vary the location of the hotspot, and each time the algorithm has managed to successfully identify the correct position of the hotspot. So in conclusion, we have established and implement the method to generate gigamolar detector dataset, and we would like to highlight that this method is flexible, so you can adapt the method to for other detector types according to your system specification. So that's all. Thank you for listening, and goodbye.
Assalamualaikum and very good afternoon. Welcome back to iNuSTEC 2020 for our last session for our conference today. This afternoon, we are very honored to have Puan Sharifah Nur Kamseh Aidit as our keynote speaker. Puan Sharifah is an innovation and nuclear advocate. She is an expert in nuclear education and training. Without further ado, I invite Puan Sharifah for her presentation entitled Nuclear Education and Training Prospect for Students and Malaysia.
Hello, can you hear me? Thank you, Madam Chairman. Thank you, Madam Chairman. I'd like to extend my sincere appreciation to the organizers, Uni 10 and the Malaysian Nuclear Society, for inviting me to present on nuclear education and training prospects for students in Malaysia. So without further ado, as we're already a little bit late because of technical issues, I would like to upload my presentation to share with you some of the views on this subject. Can you see? May I know, can you see my slides? Organizers, may I check whether can you see my slides? Hello? Can you see my
Yes.
slides?
Yes, we can see your slide. All right.
All right. Thank you, Madam Chairman. Okay. I will go right through. My presentation will cover the compelling factors for nuclear power in operation in 2005, and the updates to this year. What is the shift in nuclear power, new build and manufacturing, the nuclear fuel cycle, nuclear new build supply chain, the milestones in development of national infrastructure, in terms of stakeholder and HRD perspective, who are the stakeholders in nuclear power program, and very importantly, organizations in the nuclear field requiring human resources, because this is the guide or the framework that facilitates nuclear education and training. Then what is the role of the organization for HRD and coordination framework, nuclear causes, Malaysia's economy, oil price trend and escalation, Malaysia's budget 2009, our economic transformation program in 2010, the launch of Malaysia's Nuclear Power Corporation, what are the nuclear courses offered by Malaysian universities, the nuclear power organizational structure during Barisan National Administration, what were the career opportunities for nuclear scientists, technologists, and engineers? And snapshot. Okay, from 2027, I will show this in Research Institute, nuclear regulatory body, as well as in international agencies. Then, what is the Pakatan Harass decision on nuclear power? Because it makes a lot of impact and influence on the career choices. Malaysian Nuclear Power organizational structure, because now it has changed. And what are now the career opportunities with this new policy decision? Then a critical question arises, the impact to nuclear engineering courses, and what is the present global and national challenges and preoccupation? And we have to understand that we need to recognize there are more serious challenges looming ahead from, in addition to our current pandemic, and nuclear energy as a part of a solution. Nuclear ENT, what is the prospects for students? And nuclear ENT, what is the prospect for Malaysia? My closing remark and an offer. Okay. The compelling factors for nuclear power, as we can see, is the volatility and escalation of fossil fuel prices, carbon emission and global warming, the increase in energy demand due to population growth, industrialization, and generating electricity at competitive costs. As we can see here, the oil shock has been quite a few occasions in the 1970s and recently in the year 2000. And also we have the temperature rise increasing, which is affecting, causing the climate crisis. And we see that there is an increase in global demand for electricity, 76%. And here, I'd like to introduce that in the year 2005, most of the reactors in operation were in North America and in Europe. But as we come to 2019, you see that the nuclear new build are moving towards Asia, right? Because of population and industrialization. So now there is a shift in nuclear power. We are seeing all this shift towards Asia. And is Asia prepared to lead? What are we doing, including Malaysia? So this is the nuclear supply chain and the nuclear fuel supply, where you have the front end and the reactor producing electricity as well as the back end. Now, this is the nuclear new build supply chain, and very importantly, we have to see when a country goes for a new build, there are various components that is important to support nuclear power. So, before the build, you have to have project management, planning and licensing, legal and financial services, nuclear consultancy services. During construction, you need project management, building and construction, plant and equipment, on-site erection and fabrication. And during operation of the nuclear plant, you need O&M, nuclear fuel supply, purchasing, technical services, waste management. And during decommissioning, you need planning and licensing as well as decommissioning. Now, this is the IAEA's milestone, so that it guides countries during all the different phases up to commissioning and operations. And we see that human resource development is one of the 19 important factors. And it's important to know who are the stakeholders, because it's not only the owner-operator, it's also the government, the regulatory body, R&D institutes, the construction stakeholders, the electric gate market, the industry, education, news media, NGOs, the general public, and internationally is the IAEA, the nuclear suppliers and owners group. These are the stakeholders, and we can see is varied. And we need to understand so that when you're doing the nuclear education and training, you have to target and offer the training to all these stakeholders. So this is an important framework in the IAEA report, which identifies organizations in the nuclear field requiring human resources. And I'd like to highlight here, for government agencies, they need to have expertise and experience in nuclear planning, nuclear policy, nuclear governance. Then when you go to the nuclear power plant, it's operation and maintenance. Then R&D organization is nuclear R&D and technology development. Then the vendors, the suppliers and designers of reactor, they need to know about nuclear businesses, nuclear construction, manufacturing. And very important also, you have radiation protection, which is required for consultancy, for training. And we have educational institutions like universities offering nuclear education and training. And we have international organizations such as the IAEA, the Nuclear Energy Agency, that looks at and discusses nuclear policy, nuclear law, governance, as well as negotiation. But I have also added two more sectors that is required. Media agencies, so that they better understand and can offer a balanced view in nuclear, as well as financial institutions. The financial sector will be more aware of what are the benefits of investing in nuclear power. Arising from that, we can see for the training, we have training. The government, the R&D institutes, the universities, the utilities, the industries, as well as associations like Nuclear Society, which I see, and I'm happy to note that Malaysia Nuclear Society is very active annually to share it with students, professionals, and government and private sector. Then you have also NDT and also Women in Nuclear and Young Generation. Now, in 2009, Dr. Narol has written a paper and identified what are the nuclear-related subjects at Malaysian universities. Here we can see UKM offers Nuclear Science Program, Radiography. University Malaya offers Bachelor of Biomedical. USM offers Medical Physics, Medical Radiation, Master of Medical. And University Putra offers research areas in Applied Radiation. UTM offers Basic Nuclear Science Technology as core subject, and others also, but all concentrating on science, on physics, on medical. Now, if we look at Malaysia's economic growth, the GDP, we can see that initially we had a very good growth in the 80s. However, there are a few dips. There's a dip here at minus 11.2, and another dip at minus 5, and this current dip of the pandemic is minus 17.1. During this financial crisis in 97-98, the GDP was minus 11. During the global financial crisis in 2008, our GDP was minus 5.8, and sadly now, during the pandemic, it's minus 17.1. So what is the response of the government to this economic recession? Oh, sorry. And here is the oil prices, which goes up, and we can see in 2008, 2007, it has gone up to nearly $150. So, what is Malaysia's response to all these global challenges? In Budget 2009, our Prime Minister, Yang Amat Berhormat Tun Abdullah, also as a Minister of Finance, had said that in order to ensure long-term energy security for the nation, we must look for new long-term solutions, and that they have to look at viable alternative energy sources such as solar, wind, biofuels, apart from exploring nuclear energy. So for the first time, there is a black and white of Malaysia's interest to explore nuclear energy as a nuclear option. Now, as we saw 2007, when we had a dip in GDP, so at that time, the government under Datuk introduced transformation program. But input from public and private sectors, list of labs and forums, and government officials and private sector were invited for 2 months to discuss and deliberate on what are the sectors, and 12 NKAEs were identified. In terms of the oil gas energy sector, Nuclear Malaysia under MOSTI was invited, and Encik Jamal Khair Ibrahim, then Director of Planning and International Affairs of Nuclear Malaysia, who is also an engineer from University of London, he was representing Nuclear Malaysia to help in giving input. For Nuclear Malaysia was to look at the potential of nuclear energy for Malaysia. And when Datuk Sri Najib launched the ETP in October 2010, we had under one of the 12 national key economic areas under OGE, the role of nuclear power. So again, for the second time, we have black and white national policy and statement on the role of nuclear. And here we can see there are a few conditions before we go for nuclear. Public acceptance, and also to make sure we follow international guidelines. And it was identified that we will have, by 2021, 2 nuclear powers for each 1,000 megawatt electric. And what is the impact? It will create 2,600 jobs, and it will generate 1.8 billion per year from electricity generated. So it has economic impact. During On 11th January 2011, during the third update of ETP, Datuk Sri Najib announced the formation of Malaysia Nuclear Power Corporation under Prime Minister's Department to serve as NEPIO, because the IAEA recommends for countries planning for nuclear power to have NEPIO. That means it's a nuclear energy planning organization. So, and its plans is to spearhead and coordinate the implementation of nuclear energy development for Malaysia. Once the government has announced very solid interest to invest in the planning of nuclear, apart from the courses that I showed in 2009, nuclear-related courses, Uni 10 under TNB had introduced electives in nuclear within its Masters of Mechanical Engineering in 2001-2012. And UTM had introduced a Bachelor of Nuclear Engineering in 2012 because they were excited in order to support Malaysia's nuclear power program to have a supply of nuclear engineers. So this is at the moment during BN rule, the organizational structure. So we have economic transformation program. We have 2 nuclear power reactors here, and we have MNPC, and we have Suruhan Jaya Tenaga, we have Tenaga Nasional, and during that time they had a nuclear energy unit. And under MOSTI, we have regulatory body, AELB, we have Nuclear Malaysia doing R&D, and we also have universities offering all the related nuclear courses. And also we have Ministry of Health, hospitals. Now, so what is the career prospects for students then? So here I showed, from university, you have various, I would say, options. 1, you continue to postgraduate. 2, you can join Nuclear Research Institute. 3, you can join regulatory body, which is AELB. 4, you can join government agencies like Ministry of Energy, etc. 5, you can join the nuclear power plant, which was scheduled to be in 2021, and then later delayed, postponed to 2030. And you can also join industry, the manufacturers of reactors. And then you can also join NDT companies and hospitals. And internationally, you can join the IAEA. Now, okay, so career opportunities for scientists in Nuclear Malaysia. We can see here, this is Nuclear Malaysia, and it conducts nuclear R&D. So these are some of the previous Director General. The reason I'm putting here is to show that Professor Datuk Nur Ramli has a Bachelor of Science, and Tan Sri Tajuddin has a PhD in Nuclear Engineering. Datuk Dr. Daud has a PhD in radioactive waste. And the current Lady DG, Datuk Siti Aisyah, has a Bachelor's in Engineering Electrical and a PhD in Physics. So that means those students with degrees in either normal science, traditional science, and nuclear science, you have a potential to work, opportunity to work in Nuclear Research Centre. Okay, here, because Nuclear Puspati, or now Mint Nuclear Malaysia, we have a Trigamak 2 reactor, and these are the past head of department of the nuclear, the reactor department. One is Tan Sri Tajuddin Ramli. The other one is Encik Jamal Khair Ibrahim. And we are also happy to announce we have Datin Zarina Masud, head of department, who's now the Vice President of Women in Nuclear. Now, in Nuclear Malaysia, there is an opportunity for its employees and staff to be appointed as science attaché in Vienna. So we have Dr. Cairo previously, we have Datuk Raja Aziz, we have Dr. Nur Hasna, and we have Dr. Muin. So what is their role? They advise the ambassador, and they are based in Vienna. They advise the ambassador on scientific technical matters. They report on technical events, and they report on S&T. Yeah. So this is another role and opportunity overseas. Now, the AELB, Atomic Energy Agency, it looks at regulation. We have Dr. Reher, Dr. Hamra. So these are the ones that look at monitoring and regulating radiation activities. Now, okay, in Vienna, there is also posts that has been taken up, appointed by Malaysians. You can see here, there is 5. Under the Director General, there are 5 Deputy Director General. And Malaysia is honoured to have 2 Malaysians appointed. One in the Department of Technical Cooperation and the other Department of Nuclear Science and Application. And Datuk Raja is the Director of the Department of Nuclear Safety. So just to share with students, not only you have opportunities to work in Malaysia, but also outside Malaysia. Now, under the Nuclear Power Corporation, which was set up, Dr. Zamzam Jaafar was from TNB. He was appointed executive officer, and he has nuclear engineering PhD in Queen Mary. Encik Jamal K. bin Ibrahim was the director of nuclear power program. He has a degree in nuclear engineering, also Queen Mary. And we have Puan Azlina, who has a BSc and MSc in nuclear science in UKM. So this was also some of the opportunities to work in terms of nuclear planning. Now, in terms of careers of Malaysian nuclear scientists in international and Malaysian, though there are many, but I just would like to share with you an illustrious, a lady called Dr. Hasnita Dato Hashim. She has a PhD in nuclear physics from Oxford. Because there was no nuclear power plant, she left actually to London, overseas, to be an investment banker. And when PH government took over, she was invited to come back and help MARA. So you see, from nuclear physicist, you can move into investment banking, and you can move now into policy helping your own country. Okay, just to share what are the careers in nuclear engineering. I'm taking is Berkeley University in California. Students with Bachelor of Science have careers opportunity which is diverse. Government agencies at all levels, national laboratories, companies that design and sell reactor, companies that sell nuclear steam generator, engineering and construction firm, as well as electric utility. So that means even though there's no nuclear power plant, ladies and gentlemen, don't worry. You have prospects. Now, Pakatan Harapan's decision on nuclear energy. We see immediately Mestek Minister has strongly said Pakatan won't build, not build plant. And the plans for nuclear power has been cancelled. Okay? And PM Tun Mahathir also said, no, we won't use nuclear power plant. And after he said that, there was a group of lobbyists who actually sent a petition to Mestek, UOB to seek and appeal to her to reconsider shutting down the MMPC. Okay. And I've also written in Malaysia Kini, The Star and Sun Daily to appeal for the government to reconsider reinstating MMPC. And I know Ashwin has also done that, and also Dr. Shukri. So now, when the PH group took over, there's no more Pemandu, there's no more plans for 2 reactor, stalled and cancelled and entirely stopped, cancelled. And MMPC no longer exists after 15 September. The nuclear energy unit in Tenaga was shut down. So the question now is, what is the impact to national nuclear engineering courses and the students? What happened? What will happen to the course? What will happen to the students? So now, what are the career opportunities? I'd like to highlight that although the plan is not forthcoming, but remember, you still have opportunities to either continue postgraduate course, go and join Nuclear Malaysia and R&D, or AALB for regulatory, or other ministries And again, industries, hospitals, although no nuclear power plant. Now, the critical question, what is the impact? Do we stop the cost? And do students stop pursuing the course? Now, what is the present global and national challenges? As we can see now, the world, including Malaysia, is being confronted with an impacted by the COVID-19 pandemic. And we see there's daily updates on how many cases, how many deaths, how many recovery. So the Malaysian government, public and private sectors are putting a lot of focus, attention and resources to address this COVID-19 pandemic. And a lot of programs, Prihatin Penjana has been identified, introduced to help rakyat, businesses and economy. But I'd like to highlight not only to students, policymakers, government, and politicians, that it is very critical for us to recognize that in addition to the current COVID pandemic, there is more severe challenges looming ahead. As we can see from this illustration, this very small pink color type is the COVID pandemic. And what happens here is the remark was be sure to wash your hands. Will be what most see pandemic, there will be economic recession. And after economic recession is a bigger challenge looming ahead is a climate change. And if nothing is done, a huge biodiversity collapse will take place. And I'd like to share also below a similar scenario where the two gentlemen, after flattening the pandemic curve, the statement is, I'll be happy when this is all over. But at the back, they do not realize that the climate change is looming ahead and will cause disruption and severity to lives, to businesses and economy. So what do we do? Lama El-Hatta, who is a consultant at the International Finance Corporation, a member of the World Bank Group, showed this illustration where future crises were represented by tsunami waves, each bigger than the one before. She explained that once COVID, which is the first wave, pink one, comes to an end, economic recession, climate change, and biodiversity collapse will follow. We will ask when the disaster will end and how, but we need to keep in mind that there is a lot other bigger crises that will follow. As a result, the government, politicians, policymakers must understand that COVID-19 and climate change must be handled at the same time, not separately. Nuclear energy as part of solution for climate crisis. We know that the clean energy sources include nuclear, hydropower, geothermal, wind and solar. They work together to reduce greenhouse gases in our atmosphere. And now many countries are having all this energy mix in order to enhance energy security as well as to address and mitigate climate crisis. Now, my comment on nuclear ENT prospects for students. Students, go ahead. Be brave and bold and pursue your interest in nuclear courses. Although Malaysia presently has no plans to build nuclear power plants. Because as you can see from the past generation, your seniors who have nuclear engineering background, nuclear science and technology, although there's no nuclear power plants, they have very successful careers in other sectors. So, Malaysian Nuclear Science and Engineer has and is holding a successful position in different sectors of the economy. Now, what is the nuclear ENT prospects for Malaysia? I would like to appeal to the government, to universities, to please maintain and sustain nuclear science and technology, nuclear medical, nuclear engineering courses, because when Malaysia is ready to consider the option to enhance energy security and mitigating climate crisis, through investing in nuclear energy, then our country will already have a pool of skilled and competent workforce to support a safe and successful nuclear power program. Last but not least, Madam Chairman, if I may add 2 more slides. Now, I have seen that both students and professionals for many years continuously have done a great job in order to prepare papers, posters, to have oral presentation and poster presentation to support iNuSTEC and iNuSTEC. So, what I would like to offer is, in order to recognize, celebrate, and honor the best oral presenter and poster presenter, I would like to pledge and present for the next years and all years ahead, iNuSTEC and iNuSTEC events, 2 trophies and cash prizes for these winners, both oral presenter as well as a poster presenter. And in memory of my husband, Jamal K. Ibrahim, who was the Director of Nuclear Power Planning, MNPC, and who contributed to the ETP, Nuclear Power Incorporated under Oil, Gas and Energy, for his love, passion and dedication to help Malaysia to plan for MPP. I would like to dedicate from my husband's name for you to have a presentation of Jamal K. Ibrahim Trophy for Nuclear Science, Technology and Engineering for the students, professionals for the subsequent iNuSTEC and iNuSTEC events. Last but not least, thank you very much for your, I would say, patience, although we had technical glitch, and thank you for offering me the full duration to present rather than cutting me off halfway. Thank you very much.
Okay, thank you very much, Puan Sharifah. It's very informative sharing presentation with us. It's like a hope for us to see we still have opportunity in nuclear field actually. Alright, we are very honored to have you here actually, even though normally we have now we are our first time doing online conference, so we bear with COVID-19 now, hopefully. All right. So one question. Now we actually see we still have opportunity and chance for our new generation to be in this field. So what is your best advice to our young generation, especially to face with this COVID-19 actually?
Okay. I would say for the students, pursue your interest and don't be distracted by the decision of no nuclear power plants. Continue pursuing nuclear education and training. And as I shared with you, actually your opportunities is so diverse that you can actually go into many sectors successfully, because the past generation has shown no plans but still can move forward. But now what I would like to encourage the students is, while we have no plans, although you can still go into Nuclear Malaysia, AELB, ministries, IAEA, please also try to have a career in the nuclear suppliers company. Companies like Rosatom, like the French, previously Arriva, but now Orano and Framatome. And then we have Westinghouse, and then we have the Korean Capco, so that you will have this diverse international exposure and experience in nuclear business. And when Malaysia is ready to go for nuclear power, then you would have this global exposure and experience, which will help the country, because then you are very skilled and competent. And we hope with that we have a safe and efficient nuclear power planning, introduction and investment for the country.
Okay, thank you, Puan Sharifah. As we look at your presentation before, we see that actually the development of in nuclear field actually is growth every year, except for a certain time that we have the recession and now the COVID. So I hope in the future we will have more opportunity with you to have our station, online station next time. Thank you very much for your time.
To that. It's my pleasure.
Thank you very much for your time.
It's my pleasure, and I look forward to supporting and helping iNuSTEC. And I hope you will accept my offer of the Jamal K. Ibrahim Trophy, as well as cash award for your best oral and poster presenter.
Yeah, sure. Thank you very much, Puan Sharifah.
My pleasure.
All right. So now we end our session for keynote presentation for iNuSTEC Conference 2020.
May I know how many participants are at this presentation? How many participants?
Participant for now we have like for poster like 24 participant, and for the presentation around 30 presentation.
30. But may I know how many audience is listening to my presentation?
Around 40 plus viewer now in online.
Okay, thank you so much.
All right. Okay.
All right. Thank you.
Okay, thank you.
Bismillahirrahmanirrahim. Assalamualaikum. Salam perdebatan. Salam iNuSTEC 2020. Sidang Dewan yang dihormati, selamat bertemu dalam persidangan akhir debat nuklear antara varsiti. Persidangan kita akan dimulakan sekarang. Ingin saya memperkenalkan diri saya terlebih dahulu. Saya Juniza Masaad, selaku Tuan Yang di-Pertua Dewan. Sidang Dewan yang dihormati, izinkan saya seterusnya untuk mempersilakan dan memperkenalkan ahli-ahli yang berhormat yang akan menyampaikan hujah-hujah serta bidasan pada persidangan kali ini. Pihak kerajaan dari Universiti Tenaga Nasional diwakili oleh Yang Amat Berhormat Perdana Menteri Muhammad Shazran Haikal Azlan, Menteri YB Muhammad Hakimi bin Muhammad Kabari, Menteri ketiga YB Anas Amjad bin Abdullah. Bagi pihak pembangkang dari Universiti Teknologi Mara diwakili oleh YB Muhammad Harits Ikwan bin Khairul Azman selaku Ketua Pembangkang, YB Ashraf Daniel bin Abdullah dan YB Amir Syahiran bin Azhan. Seterusnya, ingin saya memperkenalkan barisan panel juri kita. Dengan penuh takzimnya diperkenalkan IR Dr. Syamsul Amri bin Sulaiman selaku Ketua Juri. Dari Tenaga Nasional Berhad, beliau merupakan graduan PhD Kejuruteraan Nuklear dari Texas A&M University, USA. Yang kedua, Dr. Azrudi bin Mustafa dari My Power, beliau merupakan graduan PhD Kejuruteraan Nuklear dari Imperial College London, United Kingdom. Kita juga mempunyai Prof. Madya Dr. Abdul Aziz bin Mohamed, merupakan Presiden Persatuan Nuklear Malaysia, graduan PhD dalam bidang bahan termaju, fokus kepada ujian tanpa musnah, iaitu NDT, dari Cranfield University, United Kingdom. Juri kita yang terakhir ialah Puan Sharifah Nur Khamsiah, alumna Imperial College London dalam bidang Innovation and Nuclear Advocate. Maafkan saya dalam bahasa Inggeris. Bukan calang-calang orangnya. Hebat-hebat belaka semuanya para juri kita. Sidang Dewan yang dihormati, usul yang akan dibahaskan pada sesi kali ini ialah Parlimen Malaysia setuju untuk menerima tenaga nuklear sebagai salah satu pilihan untuk bahan api negara. Walau bagaimanapun, Parlimen memutuskan pendekatan untuk pengurusan sisa bahan api nuklear negara. Sama ada kitaran terbuka maupun kitaran tertutup. Kerajaan mencadangkan pengurusan sisa bahan api nuklear secara terbuka, iaitu open loop cycle dalam bahasa Inggerisnya, seperti Switzerland yang membina repository sisa bahan api jangka masa lama. Manakala dari pihak pembangkang berpendapat Malaysia patut mengikut kaedah Perancis dalam mengitar semula bahan api nuklear terpakai negara, iaitu closed loop system dalam bahasa Inggeris. Adalah diharapkan agar ahli-ahli yang berhormat akan menumpukan hujah dan bidasan kepada usul tersebut. Sidang Dewan yang dihormati, kita mulakan tirai perbahasan pada hari ini dengan ini saya mempersilakan Yang Amat Berhormat Perdana Menteri Muhammad Shazran Haikal tampil untuk mengemukakan usul perbahasan, menyampaikan definisi dan membahaskan isu tersebut bagi pihak kerajaan. Dipersilakan Yang Amat Berhormat.
Cubaan suara 1, 2, 3. Assalamualaikum dan selamat petang. Saya titipkan buat Yang di-Pertua Dewan, sahabat perwakilan kerajaan, pembangkang seterusnya, seluruh penonton yang menyaksikan sidang pada kali ini. Terima kasih kerana melapangkan masa. Tuan-tuan dan puan-puan, selaku Yang Amat Berhormat Perdana Menteri pada hari ini, saya akan menggagaskan satu usul perubatan yang berbunyi kerajaan mencadangkan pengurusan sisa bahan api nuklear secara terbuka, iaitu open loop cycle. Maklumat perdebatan pada hari ini ialah kita ingin menilai pengurusan sisa bahan api nuklear secara terbuka, open loop ataupun secara mengitar semula bahan api nuklear ini adalah lebih praktikal. Justru, di meja perwakilan kerajaan, kami percaya dan yakin bahawa pengurusan sisa bahan api secara terbuka lebih sesuai diaplikasikan di Malaysia sekaligus lebih praktikal, tuan-tuan dan puan-puan. Beban bukti perwakilan pembangkang ada dua. Pertama, mereka perlu buktikan bagaimana pengurusan sisa bahan api secara kitar semula closed loop ini lebih praktikal untuk diaplikasikan di Malaysia. Dan yang kedua, mereka perlu buktikan bagaimana open loop ataupun kitaran secara terbuka ini tidak memberikan keuntungan kepada negara Malaysia. Tuan-tuan dan puan-puan, saya bergerak pada gerakan saya yang pertama, pendefinisian usul. Di meja kerajaan, kami cerakakan usul kepada dua fragmen kata. Pertama, pengurusan sisa bahan api. Menurut World Nuclear Organization, pengurusan sisa bahan api merujuk kepada satu proses yang paling penting selepas penjarahan elektrik di sesebuah stesen jana kuasa nuklear. Dan terdapatnya produk-produk ataupun sisa-sisa nuklear yang telah dihasilkan seperti uranium tailing, transuranic waste, low level waste dengan izin tuan-tuan dan puan-puan. Tahukah anda wujudnya dua kaedah pengurusan sisa bahan api nuklear? Pertama, secara terbuka open loop, dan yang kedua, kita semula secara closed loop, tuan-tuan dan puan-puan. Selesai frasa pertama. Frasa kedua, open loop cycle, tuan-tuan dan puan-puan. Open loop ini merupakan satu sistem pengurusan yang menanam ataupun melupuskan sisa-sisa bahan nuklear di kawasan yang selamat dan pada kedalaman kira-kira 900 meter. Berbanding closed loop cycle ataupun kitar semula ini merupakan satu proses mengitar semula bahan ataupun sisa nuklear ini untuk dijadikan sebuah ataupun satu produk yang boleh diguna pakai semula. Tuan-tuan dan puan-puan, selesai pembentangan definisi di perwakilan kerajaan. Jika tidak ada apa-apa di perwakilan pembangkang, saya kira mereka masih bersetuju dengan premis di perwakilan kerajaan. Tadi perwakilan kerajaan bagi saya akan membentangkan hujah pertama atas kata kunci practicality open loop. Yang kedua, bangkit Datuk Abel akan membentangkan dua hujah. Pertama, atas kata kunci kesukaran dan konflik closed loop, dan hujah ketiga di meja perwakilan kerajaan iaitu cabaran militer, cabaran keganasan, dan bangkit Datuk Anas yang ketiga akan membidas dan meranapkan keseluruhan kes di perwakilan pembangkang. Baiklah, saya mulakan dengan hujah perdana perwakilan kerajaan atas kata kunci practicality open loop cycle, tuan-tuan dan puan-puan. Dalam hujah ini terdapat tiga perkara yang saya nak utarakan. Pertama, saya akan tunjukkan kemampuan Malaysia dalam mengaplikasikan sistem open loop. Kedua, perbanding ataupun beza banding antara sistem closed loop ini dan open loop, yang manakah lebih cost efektif. Dan pada akhirnya saya akan tunjukkan bahawa return of investment ataupun pulangan melalui open loop ini lebih menguntungkan buat negara. Tuan-tuan dan puan-puan, kenapa kita ingin laksanakan open loop cycle ini? Pertama, kita perlu berada di keadaan realiti. Bagaimana Malaysia hari ini baru sahaja nak membina satu stesen jana kuasa nuklear yang pertama di Malaysia. Malah persamaan Malaysia dan Switzerland adalah apabila kita mempunyai keluasan kawasan bertanah ataupun jumlah loji jana kuasa yang di Switzerland yang hanya 4, tidak jauh dengan kita berbanding negara Perancis yang mengamalkan closed loop. Mereka sudah pun lama mempunyai loji jana kuasa ini dan pada hari ini mempunyai 56 stesen jana kuasa nuklear, malah dengan kawasan mereka yang terhad sebanyak 643,000 km persegi, mereka perlu untuk melaksanakan closed system ini disebabkan dengan jumlah tanah yang kecil, dengan banyaknya kuantiti ataupun amount stesen jana kuasa ini menyebabkan perlu mereka laksanakan closed loop berbanding Malaysia yang baru nak ada satu ini, tuan-tuan dan puan-puan. Itu yang pertama. Yang kedua, saya tunjukkan bagaimana perbandingan kos di antara closed loop dan open loop. Tahukah anda, menurut Boston Consulting Group and Kennedy Studies menyatakan pada tahun 2016 bahawa kos untuk memproses bahan api dan sisa nuklear adalah sebanyak $30 Amerika per kilogram lebih mahal berbanding kaedah pelupasan ataupun open loop ini, tuan-tuan dan puan-puan. Malah, kita perlu menggunakan sebanyak 20 bilion dolar Amerika untuk memproses kira-kira 2,000 metrik tan sisa nuklear. Namun, hakikatnya pada akhirnya kita hanya dapat menyita semula jumlah 6% daripada keseluruhan sisa nuklear yang kita itu, tuan-tuan dan puan-puan. Itu yang pertama. Yang kedua, bagaimana apabila kita closed loop ini memerlukan kecanggihan teknologi yang cukup tinggi dan Malaysia tidak bersedia. Namun jika pembangkang terlalu berdegil, kita terpaksa untuk laksanakan dengan memanggil tenaga-tenaga pakar daripada luar untuk datang ke Malaysia dan secara tidak langsung akan bekerja di Malaysia dan akan menutup ruang pekerjaan kepada rakyat Malaysia, tuan-tuan dan puan-puan. Dalam pengujian ini, saya telah tunjukkan kepada anda bagaimana wujudnya practicality open system ini di Malaysia berbanding closed system yang tidak begitu praktikal di Malaysia, melihatkan kepada kos dan sebagainya, tuan-tuan dan puan-puan. Jadi, di meja perwakilan kerajaan kita rasional dengan melihatkan kepada kemampuan Malaysia dalam melaksanakan open loop system ini, tuan-tuan dan puan-puan. Mohon untuk mencadang. Assalamualaikum.
Bagi pihak Dewan, saya mengucapkan terima kasih kepada Yang Berhormat Perdana Menteri atas hujah yang dikemukakan. Seterusnya, dipersilakan pula YB Muhammad Harith Ikhwan selaku Ketua Pembangkang untuk menyampaikan hujah serta membahaskan isu tadi bagi pihak pembangkang. Dipersilakan.
Assalamualaikum dan selamat sejahtera. Yang berhormat Tuan Speaker Dewan, rakan-rakan berkarisma delegasi pembangkang, yang berhormat pihak kerajaan yang sudah cukup yakin dengan isu usul yang dibawa pada hari ini, barisan pegawai persidangan serta hadirin dan hadirat sekalian. Salam perpaduan, salam perdebatan dan salam kelestarian alam. Saya selaku Ketua Pembangkang pada hari ini dengan tegasnya menolak usul yang dikemukakan oleh pihak kerajaan dan seterusnya mengemukakan usul supaya pendekatan untuk menyita setengah bahan api nuklear terpakai negara adalah melalui kaedah closed loop cycle. Tuan Yang Dipertua serta sidang Dewan yang dimuliakan. Beberapa minggu yang lalu, berdasarkan premis pertama mereka di perwakilan kerajaan iaitu menggunakan kaedah open loop cycle adalah lebih praktikal berbanding closed loop cycle, iaitu yang pertama. Jadi kami di pihak pembangkang akan membidas dengan cara kami mengaku bahawa ini lebih praktikal kerana ini mudah dijalankan. Kerana sisa bahan nuklear yang kita telah gunakan, kita hanya ambil dan kita tanam. Ya, memang kalau kita tanya orang lain ataupun orang awam, memang ini ternyata lebih mudah. Tapi adakah ini satu solusi yang terbaik bagi menjamin keselamatan negara pada masa akan datang? Dan seterusnya, Tuan Yang Dipertua serta ahli-ahli Dewan, saya akan meneruskan lagi dengan definisi. Menurut Kamus Dewan, definisi bagi sisa bahan api ialah sisa yang mengandungi bahan radioaktif. Dan definisi bagi frasa closed loop cycle merupakan sisa bahan api yang diproses dan digunakan semula di dalam reaktor nuklear yang sama atau reaktor nuklear yang berlainan. Oleh itu, saya teruskan lagi dengan hujah saya yang pertama bagi pihak pembangkang, iaitu kelebihan jika kita menggunakan closed loop cycle, iaitu sistem yang mana menggunakan kaedah kita semula ialah dapat memaksimalkan penggunaan sumber bahan api yang sedia ada di negara kita maupun di seluruh dunia. Untuk pengetahuan tuan-tuan dan puan-puan ataupun seperti yang tuan-tuan dan puan-puan sedia maklum, sisa bahan api terdiri daripada 3 jenis ataupun 3 komponen utama, iaitu yang pertama kita ada uranium, dan yang kedua kita ada plutonium, dan yang ketiga kita ada sisa bahan berbahaya yang tidak boleh dikita semula. Jadi kita mengambil uranium dan plutonium yang mana ini adalah sisa bahan yang boleh dikita semula ataupun diguna pakai. Manakala sisa bahan yang berbahaya yang saya sebutkan tadi merupakan sisa bahan nuklear ataupun sisa bahan radioaktif yang tidak boleh digunakan. Jadi seterusnya, kita mengambil uranium dan plutonium ini dan kita gabungkan untuk menghasilkan untuk menghasilkan satu jenis bahan api yang baru yang mana ianya boleh digunakan semula di dalam reaktor nuklear yang sedia ada ataupun reaktor nuklear yang lain. Dan hal ini seterusnya akan dapat menjimatkan sumber bahan api yang sedia ada di negara kita. Kerana kita sedia maklum bahawa permintaan bahan api di negara kita maupun di seluruh dunia saban hari semakin meningkat. Semenjak evolusi tenaga nuklear mula diperkenalkan sejak awal 1940-an, kita boleh lihat bahawa harga bahan api pada ketika itu jika dibandingkan dengan hari ini sudah semakin meningkat. Jadi saya percaya bahawa jika kita dapat memaksimalkan sesuatu penggunaan bahan api itu seperti yang saya cadangkan tadi ialah jika kita menggunakan closed loop cycle yang mana kita menyita semula, kita akan dapat memaksimalkan penggunaan sumber bahan api tersebut. Jadi sekiranya kita tidak mengaplikasikan closed loop cycle ini, lama kelamaan saya mengaku bahawa bahan api ataupun bahan api radioaktif yang sedia ada lama-lama akan habis. Kami di pihak pembangkang mengaku benda itu. Namun kita boleh mengambil pendekatan ataupun cara bagaimana untuk menggunakan sumber bahan api ini secara berhembang. Jika kita telah menghabiskan kesemua bahan api yang ada sekarang, jadi persoalan yang timbul adalah apa yang tinggal untuk generasi selepas kita? Apa sumber tenaga yang boleh mereka gunakan? Kita perlu berfikir sejauh itu, tuan-tuan dan puan-puan. Dan seterusnya, jika kita dapat memaksimalkan penggunaan sumber bahan api yang sedia ada, kita juga akan dapat mengelakkan pembaziran tenaga daripada berlaku. Kerana konsep kita semula adalah kita menggunakan semula sisa bahan api yang kita telah pakai tadi. Jadi untuk menjawab persoalan daripada pihak kerajaan yang mana YB Menteri telah mengatakan bahawa hanya 6% daripada sisa bahan yang kita semula itu yang boleh digunakan. Ya, betul, 6%. Tapi saya yakin dan percaya bahawa jika penyelidikan ini diteruskan, saya yakin dan percaya bahawa daripada 6% itu mungkin akan menjadi 50%. Bahkan mungkin lebih daripada itu. Jadi saya yakin dan percaya bahawa cara untuk melupuskan sisa bahan radioaktif adalah yang terbaik menggunakan kaedah closed loop cycle di mana kita menyita semula bahan. Saya rasa sampai di situ saja untuk ujian saya pada kali ini. Saya izinkan izin laluan daripada pihak pembangkang jika ingin membangkang kenyataan saya.
Silakan YB Hakimi.
Yang pertama sekali berkenaan perprosesan semula minyak, yang berhormat berbicara seolah-olah kita akan kitar semula 100% daripada sisa buangan itu. Sedangkan mengikut kajian saya, hanya 1% saja bahan tersebut yang akan dikitar semula, iaitu plutonium. Sisa-sisa seperti uranium dan sebagainya masih lagi akan kekal dan masih akan mengeluarkan fisi radioaktif. Jadi apa pandangan anda?
Saya berpandangan bahawa mengikut kajian yang saya telah lakukan, plutonium dan uranium itu sebenarnya boleh digunakan semula mengikut kajian yang terkini. Saya tak pasti YB Menteri dapat maklumat yang sahih ataupun tidak, ataupun maklumat daripada mana. Tapi saya yakin dan pasti bahawa plutonium dan uranium yang saya sebutkan tadi boleh dikitar semula untuk menghasilkan sejenis bahan api yang baru, yang mana kita boleh gunakan bahan api ini untuk dimasukkan semula ke dalam nuklear reaktor dan seterusnya mampu untuk menjana tenaga elektrik yang lebih banyak pada masa akan datang. Itu jawapan saya. Sekian, terima kasih.
Terima kasih kepada YB Ketua Pembangkang atas hujah yang dikemukakan sebentar tadi. Perbahasan dalam persidangan parlimen sesi ini diteruskan lagi. Dengan ini, saya mempersilakan YB Muhammad Hakimi bin Muhammad Khabari dari pihak kerajaan untuk mengemukakan bidasan dan hujah-hujah beliau. Dipersilakan YB.
Cuba suara. Okay, semua boleh dengar saya? Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam perdebatan saya ucapkan buat semua. Tuan-tuan dan puan-puan, tanya kepada anda semua kerana boleh berbincang dan berdebat tentang nuklear pada jam 3.45 petang. Namun, dalam kepanasan petang ini, dalam kemengantukan anda semua, masih penting untuk pihak pembangkang membaca sejelas-jelasnya usul perdebatan pada hari. Kerana apa? Usul kita pada hari ini bukan sahaja menuntut untuk kita berbincang yang mana lebih baik, sama ada open loop system ataupun closed loop system. Malah kita perlu membanding bezakan dan mencari solusi paling optimum terhadap penggunaan nuklear tersebut di negara kita. Sayang 1000 kali sayang, ketua pembangkang di seberang sana hanya menceritakan tentang semua kebaikan closed loop system ini. Namun sedar atau tidak, beliau tidak pernah sekali pun menyentuh kesesuaian Malaysia untuk mengaplikasikan kegunaan teknologi ini. Saya berikan anda satu analogi mudah. Kalau kita mahu membandingkan antara sebuah kereta pacuan 4 roda dan juga sebuah jentera BMW, maka dalam semua situasi, jentera BMW ini akan menang. Enjinnya lebih kuat, keretanya lebih cantik, lebih mahal dan sebagainya. Namun, apabila anda seseorang yang tinggal di dalam hutan, maka kereta pacuan 4 roda itu lebih sesuai untuk anda. Maka inilah situasi kesesuaian yang kita mahu dan kita cari dalam persidangan. Jadi, mari kita teliti terlebih dahulu bidasan beliau terhadap hujah yang telah dibentangkan oleh Datuk Syazran sebentar tadi. Datuk Syazran telah terangkan kepada anda bagaimana dalam status quo semasa, sebagai negara yang mahu berjinak-jinak dengan tenaga nuklear, kita tidak perlu untuk melaburkan kos berbilion-bilion ringgit semata-mata untuk mengitar semula minyak ini. Malahan kami juga telah tunjukkan kepada anda bahawa kadar kitar semula ini hanya berada pada tahap 6% sahaja. Bermaksud, kita boleh gunakan sahaja dana tersebut untuk mencari alternatif lain yang lebih bagus serta lebih mesra alam, tuan-tuan dan puan-puan. Dan semua hujah Datuk Syazran tentang kesesuaian dengan negara kita langsung tidak dijentik oleh beliau. Jadi, saya fokuskan kepada hujah beliau. Hujah pertama, open loop cycle ini mudah dijalankan dan lebih selamat di masa hadapan. Pertama sekali, tuan-tuan dan puan-puan, anda perlu tahu seperti yang telah saya celah sebentar tadi, hanya kerana kita memproses semula minyak tersebut, kita tidak membuang sisa-sisa tersebut. Sebab, apa yang membawa sisa radioaktif yang banyak ke dalam alam semesta kita ialah pelakuran daripada sisa-sisa uranium. Manakala yang dikitar semula ini adalah plutonium, tuan-tuan dan puan-puan, yang hanya merangkumi 1% sahaja daripada minyak-minyak yang dibuang daripada reaktor nuklear ini. Bermaksud kalau kita kitar semula sekalipun, sisa tersebut masih akan ada. Yang kedua, beliau juga ceritakan kepada kita bahawa satu ketika nanti kita akan kehabisan uranium kalau kita tidak kitar semula. Habislah kita semua. Tuan-tuan dan puan-puan, anda tahu atau tidak bagaimana uranium ini wujud? Apabila matahari membebaskan cahaya dan menyejatkan air-air, maka uranium ini akan jatuh ke dalam tanah-tanah. Seterusnya kita boleh gali. Dan mengikut kajian daripada Nuclear Energy Agency, kita mempunyai storan uranium sebanyak 200 tahun lagi, tuan-tuan dan puan-puan. Jadi masalah kita tidak akan cukup uranium dan sebagainya ini, saya kira bukanlah hujah yang relevan. Malah kita ada banyak lagi sumber mineral lain seperti thorium yang turut boleh digunakan dalam penjanaan tenaga nuklear, tuan-tuan dan puan-puan. Jadi, sebelum saya teruskan dengan hujah saya, sekiranya ada sebarang celahan. Saya kira tiada. Jadi saya teruskan dengan, sebelum bergerak pada hujah utama, saya cuma mahu berikan sedikit penjelasan bagaimana di negara kita, kita langsung tiada desakan untuk mengejar sistem closed loop ini, tuan-tuan dan puan-puan. Kenapa? Negara-negara lain seperti Jepun dan juga Perancis, mereka tiada alternatif lain. Jepun merupakan satu negara kepulauan, Perancis merupakan negara yang sudah pun mempunyai 56 reaktor nuklear dan tidak ada lagi storan nuklear untuk digunakan. Malaysia bagaimanapun, langsung tiada kekangan sebegitu, maka kita perlu pertimbangkan alternatif lain serta faktor lain untuk mengambil keputusan ini. Jadi, inilah hujah yang akan saya bincangkan dengan anda semua, iaitu ancaman terorisme serta keselamatan negara. Bagaimana hujah ini boleh wujud? Pertama sekali, dalam sistem open loop, tuan-tuan dan puan-puan, kesemua sisa buangan plutonium, uranium dan sebagainya ini akan disimpan di pusat depository dengan izin yang dipertua ataupun penghimpunan sisa terbuang di dalam tanah 900 meter sekurang-kurangnya. Oleh kerana pusat penghimpunan ini berada sangat jauh di dalam kedalaman bumi, ianya sangat besar, ianya sangat berat dan ianya sangat beradioaktif tinggi. Maka ianya mustahil untuk dicuri ataupun disalahgunakan oleh mana-mana pihak di dalam dunia ini. Namun, dalam sistem gelung terbuka, sisa nuklear terbuang ini akan diproses oleh pusat-pusat pemprosesan semula yang lain. Terutamanya apabila ianya sudah dikomersialkan. Seperti di Perancis, mereka sudah memberikan kontrak-kontrak kepada pengusaha pusat pemprosesan ini. Apabila anda mengagihkan sisa nuklear ini ke seluruh negara, bahan-bahan terbuang tersebut sukar untuk dikesan oleh pihak berkuasa. Bermaksud ada sedikit plutonium dan uranium pergi ke Kelantan, ada yang pergi ke Johor, ke Sabah dan sebagainya. Jadi apabila bahan-bahan radioaktif ini sukar untuk dikesan, risiko untuk bahan-bahan ini disalahgunakan amat tinggi. Malah untuk pengetahuan anda semua, hanya kurang daripada 10 kg plutonium sahaja diperlukan untuk membina satu bom nuklear yang mampu untuk mendatangkan kerosakan yang besar. Ini membawa kepada lapisan kedua hujah saya, iaitu ancaman terorisme. Baik, oleh kerana tidak diterangkan dengan baik oleh Ketua Pembangkang, saya akan terangkan kepada anda semua bagaimana sebenarnya kita proses semula sisa buangan ini. Pertama sekali, kita akan ambil sisa-sisa buangan tersebut, kita akan masukkan ke dalam kolam untuk beberapa tahun bagi menyejukkan sisa yang sangat panas ini. Jadi, kemudian ini akan melalui satu proses yang dikenali sebagai vitrification dengan izin yang
Hakimi, 1 minit.
Jadi, apabila sisa ini diletakkan di dalam kolam, ianya tidak terkambus di dalam tanah. Anda sedar atau tidak, sayang seribu kali sayang, Malaysia merupakan salah sebuah negara yang sering menjadi ancaman terorisme. Kita ada ahli-ahli negara kita, ahli warga negara yang pergi menyertai ISIS di Syria dan sebagainya. Oleh itu, apabila kita biarkan saja pusat-pusat pembuangan ini terbuka begitu saja, ini akan mengakibatkan risiko ancaman yang sangat tinggi. Malah, kita tidak mempunyai kesediaan seperti negara Perancis yang mempunyai kerjasama antarabangsa yang baik, sistem keselamatan yang canggih dan sebagainya. Kita masih lagi dalam proses pembangunan, kita tidak mempunyai kekuatan ketenteraan yang cukup baik untuk menjaga diri kita daripada ancaman-ancaman ini. Rangkuman daripada ucapan saya pada hari ini, saya telah tunjukkan kepada anda bahawa pihak pembangkang sudah pun terlari daripada kiblat perdebatan. Mereka tidak sedar. Hari ini kita bukan hendak mencari siapa yang lebih baik antara keduanya. Kita hendak mencari yang mana paling sesuai untuk dijalankan di Malaysia. Dan berdasarkan apa yang setelah saya ceritakan kepada anda, maka benarlah open loop system lebih baik dan lebih optimum untuk dijalankan di negara kita. Mohon untuk terus mencadang. Assalamualaikum.
Terima kasih diucapkan kepada YB Muhammad Hakimi bin Muhammad Kabari. Isu perbahasan yang semakin hangat dibahaskan ini diteruskan lagi. Dengan ini, saya mempersilakan YB Ashraf Daniel, pembangkang kedua bagi pihak pembangkang untuk mengemukakan bidasan dan hujah-hujahnya. Dipersilakan YB.
Bismillahirrahmanirrahim. Terima kasih Tuan Yang di-Pertua, rakan-rakan di Kabinet Kerajaan, kami di pihak pembangkang dan seterusnya, ahli-ahli yang berhormat sekalian. Assalamualaikum warahmatullahi wabarakatuh dan selamat bersidang. Sekali lagi, kami dari tonggak barisan pembangkang ingin meneruskan untuk meminda usul yang dibawa oleh kerajaan dengan menyatakan bahawa pelaksanaan tenaga nuklear berasaskan tenaga nuklear berasaskan pengendalian sisa logik nuklear berasaskan close loop cycle adalah lebih wajar dilaksanakan pada hari ini. Tuan Yang di-Pertua, sebelum saya mengutarakan hujah yang saya akan lontarkan sebentar saja lagi, izinkan saya untuk membidas kenyataan yang telah dibawa oleh pihak kerajaan seperti tadi di bawah kata kunci cabaran ataupun cabaran yang mereka hadapi jika mereka aplikasikan sistem open loop. Yang saya dapat petikan daripada mereka yang mengatakan Malaysia tidak bersedia dari sistem nuklear di negara kita. Tuan Yang berhormat, kita mesti melihat bahawa persediaan Malaysia di negara kita ini adalah bersedia sebenarnya yang buat. Seperti contoh, pada tahun 2009, Perdana Menteri kita pada waktu itu, Tun Seri Najib bin Abdul Razak telah pergi sendiri ke Korea Selatan untuk mengadakan hubungan kerjasama dengan Korea Selatan bagaimana mereka membangunkan sistem nuklear tersebut. Oleh itu, di kerjasama tersebut, kita dapat hukumkan bahawa Malaysia sebenarnya sudah bersedia dari segi ilmu, dari segi pelaksanaan mereka. Tapi dari segi risiko keselamatan pengendalian sisa logi itu sendiri, tidak tahu lagi bagaimana Malaysia untuk bangunkan lagi. Oleh itu, closed loop open adalah perkara yang terbaik. Dari segi keselamatan pula, Perdana Menteri telah mengatakan bahawa Timbalan Perdana Menteri telah mengatakan bahawa peruntukannya banyak untuk membina satu tenaga nuklear. Oleh itu, saya merancangkan kami di pihak pembangkang untuk melaksanakan tenaga nuklear berasaskan small modular reactor di mana lebih ringkas dan lebih kecil dan lebih fleksibel dan dari sistem pengendalian sisa bahan nuklear tersebut melalui sistem close open kerana lebih senang kerana kita menggunakan semula bahan bakar tersebut menjadikan tenaga. Tamat dengan bidasan yang telah saya bentangkan sebelum tadi. Oleh itu, saya teruskan lagi dengan hujah kedua saya di bawah kata kunci mesra alam. Kenapa saya mengatakan ia mesra alam? Close loop cycle dalam mesra alam. Yang pertama sekali saya mengikutikan daripada Denis DP, iaitu Naib Presiden Kanan dan Ketua Bahagian Bahan Bakar Nuklear EDF di Perancis. Kita semula barangan bakar nuklear adalah elemen utama strategi kerana mereka telah lebih pengalaman lebih 30 tahun dalam industri ini. Yang berhormat, kita dapat rangkumkan bahawa penggunaan close loop cycle ini telah lama diaplikasikan di negara Perancis. Jadi tiada apa masalah kita aplikasikan di negara kita. Oleh itu kita dapat memaksimumkan penghasilan sisiologi nuklear secara tidak langsung, kesan kepada alam sekitar dan masyarakat dapat memberi kesan yang baik. Yang dipertua, berkenaan dengan sistem ataupun berkenaan dengan keselamatan tidak boleh dikompromi yang dipertua kerana kita dari pihak pembangkang perlu menitikberatkan tentang hal ini yang dipertua. Sebelum itu saya terangkan bahawa penghasilan tenaga sebenarnya yang dihasilkan oleh closed loop cycle iaitu uranium sebanyak 96%, plutonium 1% dan hasil bahan radioaktif yang tinggi hanya menghasilkan sebanyak 3% yang dipertua. Jadi penghasilan radioaktif tersebut sisa bahan nuklear hanya 3%. Jadi ia baik dapat dengan segi melimit penggunaan isi padu sekaligus mengurangkan bahan bakar nuklear. Oleh itu yang dipertua, saya hendak tekankan apabila kita menggunakan balik bahan bakar, ia mengurangkan risiko menghasilkan sisa loji nuklear menghasilkan loji nuklear dengan kuantiti yang sedikit berbanding open close loop dan menghasilkan sisa bahan loji yang nuklear yang lebih banyak. Dari secara strategi ni yang dipertua, Perancis sendiri telah melaksanakan close loop ni dan hasilnya yang dipertua, dari segi tahap pencemaran udara di dunia, Perancis tidak tergolong dalam top ataupun 20 negara yang teratas paling tercemar di dunia yang dipertua. Jadi keberhasilan tenaga nuklear tersebut dari segi pengendalian sisa bahan nuklear, jadi Perancis tidak dapat disangkal lagi. Seterusnya saya teruskan dengan hujah saya yang ketiga, iaitu berkaitan dengan variasi cara yang boleh dilaksanakan dalam pengendalian closed loop cycle. Yang dipertua, hal ini kerana setiap peringkat di cycle yang dipertua memerlukan proses yang pelbagai untuk dilaksanakan. Antara beberapa proses yang boleh dilaksanakan, yang pertama ialah pengekstrakan pelarut, pertukaran ion, perhabroran, elektrokimia dan selain dan sebagainya, asalkan ia berdasarkan proses kimia yang dipertua. Justru itu, kesan kepada pengendalian tersebut tidak menjadi satu masalah kerana kita memaksimumkan sebanyak mungkin hasil bahan radioaktif. Oleh selain itu yang dipertua, jika kita terdapat cara dari segi pengendalian, ia tidak langsung memberi kesan kepada peluang pekerjaan negara kita juga yang dipertua. Kami dari pihak pembangkang tidak hanya pandang closed loop cycle ni hanya dari segi keselamatan dan keamanan saja yang dipertua. Daripada segi ekonomi juga, daya akan bertambah juga kerana tenaga kerja amat diperlukan untuk mengendalikan proses tersebut yang dipertua. Apabila tenaga kerja yang ramai, boleh buah fikiran pun ramai, tenaga untuk mengendalikan sisa bahan radioaktif akan mencapai 100% yang berhormat. Oleh itu, berdasarkan kenyataan American Nuclear Society menyatakan cara pengendalian cycle loop sendiri akan dilaksanakan pada masa akan datang, memandangkan kaedah atau cara pengendalian radioaktif yang terjamin keselamatannya berbanding open loop. Oleh itu kita nampak Amerika Syarikat sendiri yang sebelum ini melaksanakan ataupun pengendalian sisa bahan nuklear secara open loop cycle, masa akan datang mereka akan menukar secara closed loop cycle. Oleh itu jelaslah bahawa bukti-bukti yang saya hujah sebentar tadi di bawah kata kunci yang pertama, pengendalian sisa bahan nuklear yang mesra alam. Yang kedua, variasi cara yang dilaksanakan dalam pengendalian closed loop adalah wajar dilaksanakan pada hari ini yang dipertua. Sekian, salam, selamat bersidang.
Terima kasih YB. Sidang Dewan yang dihormati, Dewan pada sesi kali ini akan lebih bergema lagi dengan bidasan daripada kedua-dua belah pihak. Dengan ini, saya mempersilakan Menteri Ketiga Kerajaan untuk mengemukakan bidasan-bidasan seterusnya memperkukuhkan kes yang dibawa oleh pihak kerajaan. Dipersilakan YB Muhammad Anas Amjad. YB.
Cubaan suara 1 2 3, cubaan suara 1 2 3, dengar ya. Bismillahirrahmanirrahim. Terima kasih kepada Tuan Yang Dipertua, sahabat perwakilan kerajaan dan pembangkang. Kita sudah sampai ke arena pembidasan, namun saya kira pada hari ini sidang Dewan masih lagi keliru dengan apa sebenarnya yang disampaikan oleh pihak perwakilan pembangkang. Kerana apa? Pada hari ini, dari yang pertama sehingga yang kedua, mereka sendiri tidak jelas bagaimanakah proses kitar semula close loop ini berlangsung, sidang Dewan sekalian. Mereka tidak jelaskan apakah yang terjadi, sama ada ketua pembangkang maupun timbalan ketua pembangkang, mereka gelapkan perkara ini. Mereka mahu mencari jalan selamat, sidang Dewan sekalian. Tapi tidak mengapa, saya akan ambil alih tugas itu. Ingin saya jelaskan kepada si isi Dewan, apakah yang berlaku. Daripada sisa-sisa yang berlaku dalam proses tenaga nuklear ini akan menghasilkan sisa seperti uranium, plutonium dan juga dangerous waste dengan izin Tuan Yang Dipertua. Namun, apa yang diproses ini hanyalah 1% daripada sisa-sisa tersebut, iaitu bahan plutonium. Bukan itu sahaja, saya akan ceritakan. Daripada satu proses plutonium itu, proses kita semula sisa nuklear ini tidak pun sebenarnya mengurangkan keperluan storan dan pelupusan. Malah, repository dengan izin Tuan Yang Dipertua masih lagi diperlukan. Buktinya apa? Selepas daripada proses reprocessing ini berlaku, bahan lebihan akan dibentuk dalam beberapa faktor. Nilai sisa nuklear ini daripada produk tersebut akan meningkat kepada 20 faktor, lebih 20 kali ganda, termasuk low level waste, iaitu sisa plutonium contaminated dengan izin Tuan Yang Dipertua. Dan sisa plutonium contaminated ini juga ialah tidak diperlukan dan masih perlu untuk dilupuskan dan disimpan sebenarnya, sidang Dewan sekalian. Jadi apakah maksud penjelasan saya pada hari ini? Maksudnya, jikalau kita mengitar semula sisa nuklear ini sekalipun, kononnya di atas kertas nampak seperti memberi kelebihan kepada kita, namun sebenarnya tidak, kerana kita masih lagi perlu untuk mengawal storan-storan produk daripada reprocessing ini sendiri, sidang Dewan sekalian. Maksudnya kita nak reproses untuk dapatkan kebaikan, tapi daripada proses reproses itu sendiri akan mendatangkan keburukan. Begitu analoginya. Baiklah, itu secara keseluruhan permasalahan yang dapat kita analisis daripada pihak perwakilan pembangkang. Baiklah, saya akan analisis satu persatu masalah yang berlaku. Yang pertama, pihak pembangkang pada hari ini tidak hadir dengan premis bangkangan yang jelas. Buktinya apa? Bangkit ketua pembangkang, mereka bangun dan mereka kata mereka akan jalankan closed loop system dengan izin Tuan Yang Dipertua. Namun, tiada bangkangan, mereka tidak katakan bahawa pada hari ini open loop system itu lebih sesuai dan lebih praktikal, selari dengan matlamat perdebatan kita pada hari ini. Mereka tidak ikut kiblat perdebatan kita pada hari ini. Seterusnya, hujah-hujah mereka ini adalah hujah yang tidak menyokong kes mereka sendiri. Hujah mereka hanya menceritakan tentang kelebihan-kelebihan closed loop system. Padahal pada hari ini, apa yang hendak kita nilai, open loop system atau closed loop system lebih praktikal untuk kita aplikasikan di Malaysia, sidang Dewan sekalian. Baiklah, kita analisis. Hujah pertama, kononnya dikatakan boleh digunakan semula sumber bahan api ini yang akan memaksimalkan penggunaan bahan api dan mengelakkan pembaziran tenaga berlaku. Itu sahaja yang dijelaskan. Namun apa yang digelapkan ialah kos. Sekiranya kita kitar semula sumber bahan api ini, ya, kita akan berjaya mengelakkan pembaziran bahan daripada berlaku. Namun, kos pula yang akan dibazirkan. Bukan sikit kos untuk kita reproses ini dengan izin Tuan Yang Dipertua. Kos yang tinggi itu tidak akan setara sekiranya kita melakukan reproses ini, tidak pun akan memberi keuntungan yang baik kepada negara kita. Dan seterusnya, kononnya mereka mengatakan hujah yang kedua pada hari ini, timbalan ketua pembangkang mengatakan bahawa negara kita sudah bersedia untuk melakukan closed loop system ini. Buktinya, Datuk Seri Najib Tun Razak telah pergi ke negara rakan seperjuangan dan kononnya mengatakan bahawa kita sudah bersedia. Tidak, bukan semata-mata ahli politik dapat menjalinkan hubungan dengan negara serantau terus kita dapat bersedia. Kita memerlukan kemahiran-kemahiran tempatan dahulu, sidang Dewan sekalian. Bukannya kononnya saya baik dengan dia terus saya dapat semua kemahiran yang ada pada dia, sidang Dewan sekalian. Seterusnya, mereka mengatakan bahawa peruntukan yang banyak kita gunakan untuk open loop system ini, mereka katakan kita guna SMR, sidang Dewan sekalian. Saya kira pada hari ini, sekalipun jika kita bangunkan SMR ini, tak menafikan yang kita masih lagi akan menggunakan kos yang tinggi dan masih lagi tidak akan memberikan pulangan yang setimpal jikalau kita melakukan closed loop sistem ini di sidang Dewan sekalian. Baiklah, hujah yang kedua mereka menceritakan kononnya mesra alam. Bukti yang dibawa mereka Perancis sidang Dewan sekalian. Sedangkan Perdana Menteri saya dari awal sudah cakap, Perancis ini negaranya besar dengan keluasan lebih 600,000 km persegi sidang Dewan sekalian, berbanding Malaysia hanya 300,000, 2 kali ganda. Dan Perancis mempunyai lebih 56 loji tenaga nuklear. Oleh itu, mereka ada nuklear yang banyak, negara mereka besar. Mereka tak cukup ruang simpanan storan. Solusi mereka bangunkan closed loop sistem sidang Dewan sekalian. Tidak dengan Malaysia. Satu loji tenaga reaktor pun belum ada. Wah, fikir sudah-sudah kita nak jalankan closed loop sistem sidang Dewan sekalian. Seterusnya, dia yang berhormat menceritakan tahap pencemaran udara berkurang di Perancis sidang Dewan sekalian. Namun tidak dijelaskan apakah signifikan kekurangan pencemaran udara ini terhadap pemprosesan semula sisa nuklear ini. Tidak dijelaskan dan akan saya ceritakan sebenarnya tidak pun ada kena-mengena pengurangan sisa nuklear ini dengan pengurangan tahap pencemaran udara sidang Dewan sekalian. Saya kira langsung luar daripada usul perdebatan. Dan hujah yang ketiga, kononnya mereka menjelaskan kepada kita akan berlaku dalam closed loop sistem ini ada variasi metod sidang Dewan sekalian, yang mana apabila variasi metod ini dapat dicapai akan ada ramai tenaga kerja dan akan boleh memungkinkan 100% kita semula. Saya kira hujah ini tidak langsung logik untuk kita bawa dalam Dewan Perdebatan. Pada hari ini 1% plutonium yang kita kitar semula itu pun hanya mampu menghasilkan 6% keuntungan. Macam manalah kita nak realisasikan 100% kitar semula sidang Dewan sekalian. Rangkuman kes daripada pihak perwakilan kerajaan pada hari ini, kami hadir dengan pembawaan yang lebih jelas. Kami telah bandingkan apakah kelebihan yang akan kita dapat daripada closed loop, open loop system dalam hujah yang pertama, dan iaitu kami buktikan practicality. Kami telah buktikan matlamat kita pada hari ini. Dan hujah yang kedua kami tunjukkan bagaimana apakah konflik serta kesukaran yang akan berlaku sekiranya kita aplikasikan closed loop system ini. Jelas, kes kami lebih kuat, kes kami lebih jelas, fakta kami lebih tepat dan tidak serong seperti pihak perwakilan pembangkang. Tiada apa yang saya pinta, mohon untuk terus mencadang. Terima kasih.
Saya benarkan celahan daripada YB Haritz.
Okey, sejak daripada YB Menteri kedua dan YB Menteri ketiga memberi usul ataupun hujah, mereka hanya memfokuskan kepada apa yang membawa benefit ataupun apa yang membawa kepentingan kepada negara. Adakah kepentingan negara lebih penting daripada kesejahteraan alam sekitar? Yang mana saya dah buktikan daripada tadi bahawa penggunaan closed loop cycle adalah lebih mesra alam.
Namun, yang berhormat tidak menafikan sekiranya kita melakukan proses open loop system akan juga membahayakan alam sekitar. Malah kami telah buktikan dalam penghujahan kami sekiranya kita gunakan open loop system ini tidak akan langsung membahayakan alam sekitar. Buktinya apa? Di loji tenaga nuklear ini adalah kawasan-kawasan yang paling selamat dengan kawasan-kawasan penyelidikan yang paling tinggi. Oleh itu saya kiranya jikalau yang berhormat sendiri pun tidak membuktikan open loop system membahayakan alam sekitar, saya kira tidak perlu celahan yang berhormat. Oleh itu tidak apa yang saya pinta, mohon usul diterima. Terima kasih.
Terima kasih diucapkan kepada YB Muhammad Anas Amjad. Perbahasan diteruskan lagi dengan memperkenalkan YB pembangkang ketiga bagi pihak pembangkang tampil untuk mengemukakan bidasan-bidasan dan seterusnya memperkukuhkan kes yang dibawa oleh pihak pembangkang. Dipersilakan YB Amir Syahiran.
Cubaan suara boleh dengar tak? Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera kepada yang dipertua, para pembangkang dan perwakilan kerajaan. Jadi berdiri saya pada hari ini adalah untuk membuktikan bahawa hujah yang diberikan oleh pihak kerajaan adalah lemah. Saya akan terus kepada hujah Perdana Menteri. Beliau berkata bahawa Malaysia baru ingin membina loji jana kuasa nuklear. Apa salahnya kalau kita bina loji jana kuasa nuklear dan sekaligus kita beri sedikit dana untuk loji pemprosesan bahan buangan itu tersebut. Seterusnya, beliau mengatakan kos untuk menjalankan closed loop cycle adalah lebih mahal berbanding open loop cycle. Saya tidak nafikan perkara itu, akan tetapi jika kita jika kita teliti dan memberi pandangan yang jauh, semakin banyak permintaan uranium daripada dunia, harga uranium akan lebih tinggi. Ini akan menyebabkan kerugian pada jangka masa panjang. Seterusnya, saya akan ke hujah YB Timbalan Perdana Menteri. Beliau berkata, dengan melakukan closed loop cycle akan menyebabkan ancaman terorisme. Beliau berkata, jika kita melakukan closed loop cycle dengan izin yang dipertua, ia akan berpotensi untuk diserang. Akan tetapi, beliau menyifatkan logi pemprosesan bahan buangan ini terbiar dan tidak mempunyai kawalan keselamatan yang kukuh. Itu silap yang dipertua. Jika kita membina logi pemprosesan hasil buangan radioaktif, kita akan memastikan bahawa kawalan keselamatan akan begitu ketat untuk memastikan tiada sebarang masalah yang ditimbulkan oleh ancaman teroris. Berbanding jika kita bandingkan dengan open loop cycle yang ditanam dalam tanah, tidak ataupun beliau berkata bahawa dia tidak akan dicapai oleh orang lain dengan kedalaman 900 meter, ia tidak membawa maksud yang benda itu mungkin bocor ataupun berlaku sebarang gangguan daripada bencana alam yang menyebabkan bekas-bekas yang digunakan untuk menyimpan bahan radioaktif itu rosak. Ini akan, kalau benda itu berlaku, dia ada jauh daripada kekawalan manusia. Ini akan menyebabkan sisa-sisa radioaktif itu mungkin bebas dan pergi ke permukaan. Sekian daripada saya, mohon untuk terus membangkang.
Saya benarkan celahan dari YB Syazran.
Yang berhormat, melalui closed loop cycle pun kita akan letak kilang tu di atas muka bumi. Andai kata berlakunya bencana dunia, yang berada di atas bumi ataupun kilang pemprosesan closed loop cycle inilah yang akan lagi terkesan, yang akan terbebas kepada alam sekitar.
Okey, jika kita buat logi pemprosesan bahan buangan radioaktif, kita akan memastikan bahawa dia mempunyai ciri-ciri keselamatan yang utama. Seperti kalau kita tengok logi jana kuasa nuklear yang lain, dia boleh ada sistem-sistem yang dijalankan untuk mengelakkan daripada kebocoran jika berlaku bencana alam yang kita tak ingini. Jadi tak mustahil kita boleh menggunakan sistem-sistem yang lain untuk memastikan kebocoran bahan sisa buangan itu daripada berlaku. Sekian jawapan daripada saya.
Demikianlah tadi kita melihat dan mendengar hujah-hujah serta bidasan-bidasan daripada ahli-ahli yang berhormat, pihak kerajaan dan pihak pembangkang. Perbahasan usul akan diteruskan dengan sesi penggulungan. Saya mulakan dengan mempersilakan YB wakil pihak pembangkang untuk tampil menyampaikan ucapan penggulungan. Dipersilakan YB Muhammad Harith Ikwan.
Assalamualaikum dan selamat sejahtera. Baiklah, bagi sesi penggulungan, saya dan mewakili pihak pembangkang akan membidas keseluruhan hujah-hujah yang diberikan oleh pihak kerajaan, kerana kami merasakan bahawa pihak kerajaan hanya memfokuskan kepada apa yang memberi kepentingan kepada negara sahaja. Mereka tidak memfikirkan isu alam sekitar, yang mana alam sekitar iaitu bumi ataupun planet yang kita duduk ini adalah lebih penting dan mengatasi segala-galanya. Dan seterusnya saya akan membidas kenyataan daripada pihak kerajaan yang mana kos yang dikatakan untuk membina closed loop cycle adalah lebih tinggi. Ya, saya mengaku, kami semua di pihak pembangkang mengakui bahawa kos yang diperlukan untuk menggunakan closed loop cycle adalah lebih tinggi. Tetapi tuan-tuan dan puan-puan, sekiranya suatu hari nanti Malaysia sudah mampu untuk membina sesebuah reaktor nuklear, kita juga seharusnya mampu untuk menyediakan dana yang diperlukan untuk melupuskan sisa-sisa bahan radioaktif ini secara berhemah. Saya bagi contoh tuan-tuan dan puan-puan. Jika tuan-tuan ingin membeli kereta seperti hujah pihak kerajaan tadi, dia menggunakan kereta, saya akan menggunakan kereta juga, tak jadi masalah kan? Okey, jika kita ingin membeli kereta, adakah kita bayar harga kereta itu saja? Tidak puan-puan dan tuan-tuan. Kita bayar harga kereta dan kita juga perlu menyediakan dana untuk proses penyelenggaraan dan perbaikan kereta itu, seperti servis, mungkin kita akan tukar tayar, kita akan repair enjin, apa semua. Jadi kos-kos itu juga kita perlu memikirkan. Jadi untuk mempertahankan hujah-hujah di pihak kami, pihak pembangkang telah menyatakan bahawa kita akan dapat memaksimalkan penggunaan sumber bahan yang sedia ada. Ya, memang tepat sekali. Dan seterusnya, kita juga akan dapat melestarikan alam sekitar. Dan juga yang ketiga, kita ada variasi penggunaan ataupun teknik pemprosesan sisa bahan nuklear yang sedia ada. Oleh itu, saya mewakili pihak pembangkang dengan tegasnya ingin menegaskan bahawa pihak pembangkang tetap dengan unsur kami, iaitu menggunakan teknik kita semula bahan api nuklear yang terpakai melalui kaedah closed loop cycle. Sekian, terima kasih.
Terima kasih YB. Ahli-ahli yang berhormat, sidang Dewan yang dihormati. Seterusnya, kita mempersilakan wakil pihak kerajaan pula tampil untuk menyampaikan ucapan penggulungan. Dipersilakan YB Muhammad Hakimi.
Tuan-tuan dan puan-puan, saya kira kita semua kalau boleh hendak hidup di dalam dunia pembangkang. Sebab dalam dunia pembangkang ni semuanya sempurna. Semua reaktor kita akan boleh bina, semua proses pusat pemprosesan semula kita akan boleh bina, kita tidak akan diserang oleh mana-mana pihak dan kita akan hidup bahagia selama-lamanya. Namun sayang, seribu kali sayang, kita sedang berdebat dalam realiti. Dan realitinya tidaklah seindah yang anda sangkakan pihak pembangkang. Baik, kita teruskan penggulungan ini dengan beberapa masalah yang saya ada dengan pihak mereka. Kita mulakan dengan serangan minit terakhir yang dijalankan oleh ketua pembangkang terhadap kami. Masalah kos. Kata beliau, kalau kita sudah cukup bersedia untuk membayar dan membina sebuah reaktor nuklear, maka sudah pasti kita ada duit untuk membeli tayar-tayar ni sekali. Masalahnya tuan-tuan dan puan-puan, kos reaktor nuklear dengan kos pemprosesan semula sistem nuklear ini hampir menelan belanja yang sama. Sebab apa? Sebuah reaktor nuklear akan menelan belanja daripada 9 hingga 30 bilion dan ke atas. Manakala, pusat pemprosesan semula sisa ini juga menelan belanja sebanyak 20 bilion. Ianya bukanlah cerita tentang membeli kereta dan mampu untuk membeli tayar, tapi ibarat membeli kereta dan membeli sebiji lagi kereta, tuan-tuan dan puan-puan. Sebab itulah masalah sebenarnya. Jadi, apakah masalah teknikal yang boleh kita perhatikan daripada ucapan ketiga-tiga mereka? Pertama, mereka langsung tidak menjelaskan sebarang situasi mendesak. Sebab apabila kita berdepan dengan pilihan antara dua alternatif, nak atau tidak, anda kena tunjukkan kenapa satu alternatif ini sangat terdesak untuk kita ambil dan tidak boleh diberikan daripada alternatif yang lain. Contohnya kalau saya sangat dahaga, diberikan ayam dan juga air, saya akan ambil air sebab saya terdesak hendak menghilangkan dahaga tersebut. Tapi kalau anda nilai satu persatu hujah mereka, langsung tiada keterdesakan yang ditunjukkan dalam hujah mereka. Hujah pertama, berkenaan mesra alam. Tuan-tuan dan puan-puan, saya nak tanya, adakah Malaysia ini sudah terdesak dalam masalah krisis alam sekitar sehingga kita perlu melaburkan 20 bilion untuk mendapat 6% semula minyak yang dikitar semula? Saya kira tidak. Malah kalau anda buka carta emisi di dalam dunia, Malaysia jauh di bawah Perancis dalam emisi karbon. Perancis mengeluarkan 380 juta tan setiap tahun. Kita hanya 240 juta tan saja, tuan-tuan dan puan-puan. Kita tidak pernah ada masalah ataupun krisis alam sekitar. Dan yang kedua, kita juga perlu faham bahawa Perancis ini 85% daripada tenaga yang dijana mereka datang daripada sumber nuklear. Maksudnya nak atau tidak, mereka terpaksa untuk mencari teknologi serta menjalankan kitar semula. Sebab mereka bergantung kepada tenaga ini. Kita mempunyai banyak lagi sumber-sumber lain. Kita ada stesen jana kuasa hidroelektrik, kita ada pembakaran daripada Petronas dan sebagainya. Jadi, saya nak tanya anda, Kalau 20 bilion ini hanya untuk mendapatkan 6% lebih tenaga, kenapa kita tidak buka saja satu lagi stesen jana kuasa hidroelektrik? Pernah atau tidak anda dengar sebarang jawapan? Saya kira tidak. Maka hujah mereka sudah pun tertolak daripada awal perdebatan. Tapi yang kedua, saya cukup...
YB Hakimi, 1 minit.
Apabila mereka langsung tidak menceritakan pembezaan antara Malaysia dan Perancis. Sebab mereka lambatkan saja. Bagusnya closed loop system ini. Bagusnya bagus dan bagus. Namun bagus tak bagus ini anda perlu nilai dan letakkan di baju anda sendiri. Adakah Malaysia sudah bersedia dan optimumkah sistem ini untuk kita? Saya kira tidak. Kami telah terangkan kepada anda bahawa dana ini tidak perlu dilaburkan sebab kita masih dalam proses pembangunan. Yang kedua, kita juga berdepan banyak ancaman daripada terorisme, keganasan dan sebagainya. Kalau kita tanam sisa-sisa ini di bawah bumi, insya-Allah ianya tidak akan diserang oleh mana-mana pengganas. Namun, kalau anda letakkan di kolam-kolam yang boleh dilihat oleh semua orang, yang boleh dijadikan sasaran, saya kira hanya menunggu masa saja keselamatan kita akan terancam. Soalan terakhir daripada pihak pembangkang. Mereka tanyakan kami, yang mana lebih penting? Keselamatan negara ataupun keselamatan alam sekitar? Saya sanggup gadaikan sedikit alam sekitar demi menjaga keselamatan saya, anak-anak saya dan bakal cucu-cucu saya. Mohon untuk terus mencadang, fikirlah masak-masak. Assalamualaikum.
Terima kasih YB. Ahli-ahli yang berhormat, sidang Dewan yang dimuliakan. Dengan ucapan penggulungan oleh pihak kerajaan itu tadi, maka berakhirlah persidangan Dewan kita pada kali ini. Dengan ini, saya mengucapkan terima kasih dan syabas kepada ahli-ahli yang berhormat serta seluruh sidang Dewan yang telah bersama-sama menjaga keharmonian Dewan ini. Saya selaku Yang Arif Tuan yang di-Pertua Dewan, dengan ini menangguhkan persidangan Dewan pada kali ini untuk memberikan ruang kepada sesi perjurian. Saya minta para YB dan sidang Dewan menunggu di talian untuk menerima keputusan dari Ketua Panel Juri sebentar lagi. Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam iNuSTEC 2020. Kembali bersiaran dalam sesi persidangan akhir debat nuklear antara varsiti. Tanpa melengahkan masa, saya menjemput barisan juri untuk memberikan sedikit maklum balas. Dimulakan dengan Dr. Azrudi, kemudian Prof. Madya, Dr. Abdul Aziz, Puan Sharifah dan diteruskan oleh Dr. Syamsul sebagai ketua juri, seterusnya mengumumkan pemenang bagi debat nuklear antara varsiti. Dipersilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi semua. Saya sebenarnya amat kagum lah dengan semua partisipan hari ini, semua yang berhujah ini. Hujah tu, walaupun saya sebelum masa saya masuk debate ni saya dah ada opinion saya sendiri, tapi dengan hujah tuan-tuan semua ni, saya macam jadi 50-50 buat seketika lah. Saya jadi macam tak apa ni. Maksudnya hujah-hujah tuan ni semua ada kesan dan saya agak impress kerana saya faham yang tuan-tuan semua tak sempat betul-betul menyelidik subjek nuklear secara keseluruhan. Tapi dengan apa yang dibentangkan, saya amat impress dengan dapat buat semua tu dalam masa yang singkat. Jadi tahniahlah kalau katakan ini adalah realiti dan ini adalah betul debate di parlimen, saya yakin Malaysia akan berada pada jalan yang agak terus untuk menuju kepada kejayaan. Komen saya yang pertama, saya nak bagi 2 komen saja. Satu kepada pihak kerajaan, Unitan, dan satu lagi kepada pembangkang. Jadi bagi pihak kerajaan, hujah memang amat baiklah, hujah yang amat convincing. Cuma ada technical error, ada satu technical error yang mana pihak kerajaan terlalu fokus kepada satu subjek itu, tapi subjek itu ada kesilapan, iaitu bila recycle adalah 1% ataupun 6%. Sebenarnya tidak. Sebenarnya bila kita reproses balik waste tu, sebenarnya dia reproses antara 95% ke 97%. Yang kira 1% tu adalah plutonium, itu betul. Tapi uranium 238, 95% tu adalah uranium 238. Uranium 238 semua boleh kita semula. Itu saja. Jadi sayangnya pihak kerajaan fokus kepada isu hanya boleh reproses 1% tu, sebab itu adalah satu yang error lah. Kalau fokus pada subjek lain yang lain, hujah lain tu semua perfect, saya pun bagi markah yang amat tinggi lah, kecuali pada kesilapan technical error tu. Bagi pihak pembangkang, sebab sebut pasal alam sekitar apa semua, sebenarnya alam sekitar adalah satu public acceptance punya isu. Public acceptance maksudnya yang tu isu yang penting bagi rakyat. Jadi saya sedih sikit lah. Bukan sedih lah. Saya ada kekurangan sikit dalam hujahan kerana tak sebut bidang public acceptance. Maksudnya kalau kita recycle, maksudnya kuranglah waste dalam bumi kita, kuranglah opposition bangkangan kepada benda nuklear dan sebagainya. Satu lagi, mining. Bila kita recycle, kita dah tak perlu korek mine dalam-dalam buat banyak kerosakan alam sekitar lagi. Jadi walaupun sebenarnya jumlah uranium dalam dunia sebenarnya banyak, tapi kekangan dia adalah 2, satu mining dan satu lagi waste management. Dan dengan recycling, boleh solve 2 benda ni sebenarnya. Itu sajalah. Itu hanya komen saya untuk kita terus maju ke depan, dan bolehlah kalau nak lepas ni kalau nak research sendiri dekat rumah, boleh continue teruskan. Tapi saya amat kagum dengan semua dan terima kasih kerana berkongsi hujah-hujah saudara-saudara sekalian dengan kami ini. Terima kasih semua.
Okay, terima kasih tadi ini. Okay, Puan Ju, boleh saya cakap? Okey, saya pun setuju dengan Tuan Azrudi. Dan saya sebagai Presiden Persatuan tu, saya kagum lah tengok dinasti Zack Biasa kalau Zack tu, kalau tengok kartun-kartun tu, dia buat Zack tu tidur kan. Jadi dinasti Zack kita ni nampaknya tak tidur lah. Dan kami dah ada buat pinjangan, kami tu agak kagum dia dengan waktu yang singkat. Okay. dah semua dapat mencari fakta dan menyusun walaupun ada terdapat beberapa kesilapan teknikal lah. Jadi saya tak nak komen lah. Saya cuma mengucap tahniah lah. Dan satu yang promosi, jangan lupa jadi ahli kita supaya kita nak orang macam ni. Dan untuk pengetahuan kita persatuan baru saja bersetuju untuk mengadakan satu chapter baru, kita panggil chapter Nuclear Professional Chapter Malaysia Nuclear Professional Chapter. So sebab dalam ni kita akan menghukumi semua lah, termasuk yang mana yang berlibat. Sebab ini semua datang daripada ahli-ahli muda dalam MNS. Dia kata dia nak lebih profesional lah. Dan sekelas saya menonton Puan Syarifah punya pemandangan tu, jadi saya kata this need to have a young and good professional. Sebab kalau kita tengok pun di negara China, mereka untuk mengajukan sebarang aktiviti industri kecerdasan teknologi, mereka melibatkan usian antara 30 hingga 45 tahun. Supaya jadi itulah. Jadi sekarang saya sudah syabas. Dan nanti kalau yang tim yang menang dan juga pendebat yang terbaik, saya ucapkan syabas kepada mereka. Terima kasih.
Disilakan Puan Syarifah.
Assalamualaikum. Terima kasih Dr. Niza. Saya juga bersama pendapat dengan juri-juri Encik Azrudi dan Dr. Aziz yang kami sungguh mengagumi the prestasi dan performance of the speakers, sebab I think masa agak suntuk untuk buat preparation, tapi hujah-hujah the members is very good, very professional. Walaupun macam Encik Azrudi kata there might be some fakta-fakta yang not so accurate, tak apa, because you have only a short time to do the research. But saya nak bersetuju dengan juri that you've done a good job, because the first thing is you articulate it very well. Cara menyampaikan hujah adalah profesional, dan di antara speaker-speaker pun ada yang sungguh berhujah dengan passion. So that is very important bila kita nak convey sesuatu. That shows atau evidence yang kita memang rasa bersungguh-sungguh committed mengenai tajuk tersebut. Secondly, saya pun nak congratulate speakers sebab cara menyampaikan hujah adalah secara diplomatik. Because in nuclear, it's not only technology. Saya selalu menekankan yang students, professional mesti juga ambil kira nuclear diplomacy. Because nuclear is a very sensitive issue. When you go for dialogue, either dengan public, dengan media, dengan national politician, parliamentarians, atau big international global conferences, it is very important for the students, the professionals, to have diplomacy. That means cara nak menyampaikan sesuatu boleh to be direct, but do it in a gentle, diplomatic way, not offending your audience, yeah? Because sometimes when we see certain discussion, some people are very, I would say mungkin dia rasa passionate dan committed sangat, tapi cara dia nak convey, dia terlepas the diplomatic punya perspektif, then it becomes a little bit aggressive. So when you become aggressive, your audience will not be able to receive or will not want to accept your ideas. So that is also important for stakeholder engagement and also public acceptance. Next time, because I see you all have potential to be great nuclear professionals, inshallah, very capable nuclear leaders. So when you need to communicate in nuclear communications, you all have the good potential for it. So shabas for that. And the other thing I'd like to agree with Azrudi, some pointers might not be too accurate, but never mind. You now have more time to read up. But the other thing I'd like to highlight is the cost of a nuclear power plant, because the cost of the nuclear power plant depends on many factors. So if you look at countries, some countries it's 5 billion, and in Finland it was supposed to be 3 billion USD per plant, tapi due to construction delay, due to a lot of problems, it has escalated double and triple. So these are some of the issues, because countries might have a certain budget for nuclear power construction, but if they do not prepare their construction workers, their manufacturers to be skilled in time so that there's no delay in construction, then the budget will be off and they might not be able to complete it successfully. Yeah. So once again, I would like to congratulate everyone for your great job, your passion, and your commitment, and wish you great success for your studies, and hope to see when Malaysia has a plant that you all will be the professional supporting and leading it. Thank you.
Silakan Dr. Syamsul.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih kepada Dr. Azrudi, Dr. Aziz, juga Puan Sharifah yang telah menyenangkan kerja saya untuk di-share kepada para pendebat lah. So seperti kata juri-juri yang lain, first and foremost, I would like to congratulate you guys for being so passionate, being so enthusiastic dalam berdebat secara ilmiah. So saya dah lama dah tak dengar debat-debat di kalangan kita punya mahasiswa lah mengenai perkara nuklear, dan daripada segi yang saya nampak, kedua-dua pihak mempunyai reputasi yang tinggi kerana both of UiTM as well as Unit 10, you guys memang dua-dua adalah juara kerana telah melepasi seringan yang mula-mula tadi. So bagi saya dalam setiap pertandingan tu, of course lah kita ada pemenang dan juga juara. So tapi seperti apa yang telah dikatakan oleh Puan Sharifah tadi, nuklear ni bukan sekadar technical. Technical ni actually we can solve all the technical problems. Sometimes only time will tell. Cumanya bila sampai ke dunia ni, nuklear ni to me, apart from diplomacy, it is also highly political. So geopolitical tu actually nobody has touched that dalam kita punya discussion, because of course it is our right to go whether you want to choose open cycle ke choose closed cycle tu, dalam nuclear fuel cycle tu is actually your right. Cumanya when you want to choose one path tu, you know, okay, these are the consequences that, okay, these are the aftermath that you need to be prepared of. So bagi saya, of course ada some technical glitch tu biasalah, tapi the way you guys berdebat tu secara ilmiah, lepas tu daripada segi strategi dan juga daripada gaya dan juga bahasa tu, I think is very commendable lah. So dengan ini saya ingin mengucapkan syabas sekali lagi, dan seperti kata Puan Sharifah tadi, she is very passionate in their field, dan saya juga ingin melihat you all semua menjadi nuclear ambassador lah, nuclear ambassador, so that you can disseminate the correct information to your colleagues. Dan of course after this, you check balik apa yang Dr. Azrudi cakap tadi tu, to get your facts right, because di dalam nuklear ni, kalau you bagi salah information, benda tu akan be politicized. Seperti walaupun 1%, 6% and all that tu, so get your fact right, and then based on that fact tu, you try to champion your content. So dengan ini saat yang ditunggu-tunggu telah tiba. So dengan sini setelah saya berbincang dengan para juri-juri kita yang mempunyai credential yang hebat-hebat ni, saya ingin mengumumkan pemenang untuk iNuSTEC 2020 tahun ni adalah jatuh kepada Unit 10. Dan juga pendebat yang terbaik, the best orator juga adalah daripada Unit 10. Dan dia adalah Encik Muhammad Hakimi. Congratulations again. Dan teruskan yang kepada yang kelima-lima yang lain tu, anda semua adalah pemenang. Markah tu sikit je yang membezakan. Tapi kerana Hakimi telah cetuskan idea analogi tu dan telah digunakan oleh semua, so kami berpendapat benda ni is second to none lah. So bagus, teruskan usaha-usaha yang murni ni. Assalamualaikum.
Terima kasih para juri. Tahniah diucapkan kepada pihak kerajaan Universiti Tenaga Nasional sebagai pemenang bagi debat nuklear antara varsiti. Juga tahniah kepada pihak pembangkang UiTM, Universiti Teknologi Mara, di atas persaingan hebat yang diberikan sebentar tadi. Tahniah juga diucapkan buat pendebat terbaik kita, YB Muhammad Hakimi. Alright. Terima kasih pada juri kita, Dr. Syamsul selaku ketua juri, Dr. Azrudi, Profesor Madya Dr. Aziz dan Puan Sharifah untuk komitmen yang diberikan dan tepukan gemuruh buat semua secara maya je lah ya. Dengan ini saya serahkan majlis kepada pengacara majlis untuk sesi berikutnya sebentar lagi. Sekian, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih semua.
Okey.
Okay, congratulations to all the winners. Now I invite Dr. Aziz for his speech for our conference iNuSTEC 2020.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Syukur Alhamdulillah kepada Allah SWT yang telah memberi kita kemudahan dan memberi kita kelancaran dalam melaksanakan teleconference iNuSTEC 2020. So, dan saya selaku Presiden dan juga pengurusi iNuSTEC ni, dan saya telah mengikuti hampir semua acara, dan saya lihat memang untuk melaksanakan iNuSTEC itu agak mencabar kerana ini dah pertama kali kita mengadakan conference persidangan iNuSTEC ni di alam maya, dan saya juga minta tahniah kepada semua yang terlibat, dan kepada kita punya pelajar-pelajar yang sama-sama turut menjayakan ni, saya ucapkan sangat berbangga, dan kerana mereka lah ni akan jadi penggerak di masa depan untuk mengenengahkan penggunaan teknologi nuklear yang sangat beri impact ekonomi kepada negara. Dan juga saya mengucap tahniah kepada pemenang-pemenang hadiah, dan kepada pemenang debat daripada Unit 10, kumpulan Unit 10, saya mengucapkan tahniah, dan sekali lagi pada semua jawatankuasa, pada organisasi yang menyokong iNuSTEC 2020, kami dari Persatuan Nuklear Malaysia mengucapkan banyak terima kasih. Dan so dengan ini sekali lagi saya mengucapkan terima kasih kepada semua. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Aziz. Now is the time for the closing ceremony. I invite Dr. Siti Aisyah for the closing speech.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Dr. Abdul Aziz Muhammad, President of the Malaysian Nuclear Society, MNS, Dr. Nasri Hamid, Co-Chair of iNuSTEC 2020, Honourable guests, ladies and gentlemen. Nuclear Malaysia has always been supporting the International Nuclear Science, Technology and Engineering Conference. In fact, many of the organising committee members are our staff, and even some who had previously worked with us. And this year the same applies, although the mean of presentation has totally moved from physical to virtual meetings. COVID-19 may prevent us from being in touch physically, but we can still connect through the cyber highway. Since the situation of COVID-19 is still vague, I would like to suggest the use of this virtually online conferencing mode being kept alive and the use of technology being enhanced. Hopefully next year we can have at least a hybrid conference. iNuSTEC 2020, I was informed that more than 70 papers, including 3 keynote speakers from Germany, Korea, and the US, and 1 invited speaker from the US, oral and poster presentation, keeping its international status. The topics covered were comprehensive, covering various aspects of nuclear science, technology, and engineering. So I must congratulate all parties involved in making this conference a success. I was informed also that concurrent to the seminar, 2 other events were held. The first one is the radiation safety refresher course for radiation protection officers, which was held in collaboration with Aerial Solutions Sdn Bhd, our industry partner. The other event, the InterVarsity Nuclear Debate 2020 had gathered participations from the local universities, namely UNITEN, UTM, UKM, and UITM. I would like to congratulate all parties, including the keynote speakers and participants of the RPO refresher course, the nuclear debate teams, Squad Media UNITEN, organizers and collaborators in making this event a success. Especially when it involved online coordination with all parties from across Malaysia and overseas. The nuclear community would definitely benefit from virtual online conferencing, especially in human resource development. Experts from overseas could be engaged to provide online training for Malaysia in nuclear science, technology and engineering, particularly for Nuclear Malaysia staff. Besides optimizing financial resources, we could select the best trainers for our staff. I would like to thank the Malaysian Nuclear Society again as the principal organizer, University Tenaga Nasional for hosting the conference, a bit virtually, Array Solutions Sdn Bhd for getting the CEP points for RPOs attending at least 80%. And I also would like to wish thank you to all the committee members for their tireless effort in ensuring the success of this virtual online conference. Due to the changing time caused by COVID-19, all participants are urged to stay safe and maintain social distancing. I would like to take this opportunity to invite also nuclear researchers, the local and international, to collaborate with us in Nuclear Malaysia in conducting research in various areas of nuclear science and technology applications. We host the only research reactor in Malaysia, the reactor Triga Puspati, the RTP, the small angle neutron scattering, SANS, neutron radiography, the NR, the facilities which are under development, such as the powder neutron diffraction, boron neutron capture for research, and prom gamma neutron activation analysis, the PGNA. We also have the industrial irradiators such as the electron beam facility, the gamma irradiator, and also the gamma greenhouse. And we have laboratories fit for nuclear related researchers. So we welcome very much any related collaborators to keep the application of nuclear for peaceful users alive. And with this remark, I would like to thank everyone again and would like to officially close this conference. Thank you. Wassalamualaikum warahmatullahi ta'ala wabarakatuh.
Okay, thank you, Dr. Siti Aisyah. Okay, I would like to thank you to the organizer, Malaysia Nuclear Society, UNITAN, and all organizer. Special thank you to all the conference participants, poster and presentation, and the debaters team, and last and not least for the Squirt Media UNITAN. See you next year.